Okay, good morning again. Okay, so I think while waiting for others to join the session, okay, let me brief you on the schedule for today. Okay. All right. Okay, so we will continue with the text manipulation part. Okay, but for today we will focus on the classifications. Okay, so the first part of what we are going to do is a continuation from last week works, which is we are still using the R and R Studio. Okay. So for text classification, we will just you will just need to install a few additional packages, okay, that we will be using. Okay. So you will see the overlaps, a little bit of overlaps, especially the text processing, the pre-processing part, okay, the pre-processing part and the representation as well. You can see there, we are going to actually revise again what we have done last week, okay, and then we will also take a look at how we can train a supervised machine learning model, okay, supervised machine learning model for textual features, using textual features. Okay, so that is the classification part. Okay, so after that, the second half, basically, yeah, we will start before lunch, lunch break. So I will introduce you to the text search and text discovery. Okay, so for this text search, we will be using a platform. Okay, so there is a minimal that there will be a minimal scripting. Basically, we are just going to use some command. Okay, yeah. So we'll be using the command to perform steps like indexing and to query. Okay, yeah. So we will take a look at the platform called Solar. Okay, how we can use it to perform text indexing and text search. Okay, so that is the second half. So at the end of the day, we will again do the assessment. Okay, so you will do the assessment again and then wrap up. Okay, okay, wait a minute. I think just a moment. Oh, the file is some up here, some down there. Okay, let me show you where is it. Okay, so these three are for the text classification. Okay, 1, 2, 3. Okay, this one supposed to, let me pull this down there. It's hard to organize. Okay, so these three PDF, okay, they are for text classification. So you can download, you can get 1, 2, 3. Okay, and then this is the script and the CSV file. Okay, yeah. So let me shift this down. Okay, that will be for the second half. Okay, so again, download this one. 1, 2, 3, the script, sample, and the CSV file. Okay, so these are the files we need for now. Right. Okay, so let me start with the overview. Okay, so let's start with the overview of text classification. All right. So yeah, there's also another name for text classifications. Sometimes you will hear that, okay, there's a document classification. Also, you may also will be seeing some phrase like maybe phrase classification. Okay, that's a bit rare, or sentence level classifications. Yeah, but when we refer to document classification, that particular document, it can be a big document. Okay, a big document like a document with maybe many pages. It can be a shorter articles. Okay, like a news. It can be, for example, again a review. Okay, if you have a long review, that can be one document. Even if you have a short review, that can be one document as well. Okay, so that's the example of the bigger one. Okay, the smaller one, maybe very small documents, we can have a tweets. Okay, yeah. So tweets classification is also a very common problem, where people try to classify tweets or try to classify the headlines. Okay, headlines. So just one line. Okay, on a news headline. Try to classify maybe a slogan. Okay, so those are relatively much shorter text. Okay. So for document classification or text classification, it actually it's falls within the field of machine learning. Okay, so we know that machine learning is under the this big umbrella of artificial intelligence. Okay, so where when you use machine to try to learn something, that means we will need to fit in the machine with some informations, or here we usually say that we are going to fit in with some data, and then we let the machine trying to pick up some clues from the data. Okay, so it depends on what's in the data. So how the machine is going to learn is it can use a certain mathematical model to perform some calculations. Okay, that's a part where it try to detect a certain pattern, okay, in the data. So once it capture, okay, it captures the informations, then that information will be stored in something like, you can call it as a model. Okay, that after you have got the model, we can use the model to apply on some new data. Okay, so how the mathematics is going to capture the patterns? So it depends on what kind of algorithm you use lah. Okay, or what kind of statistical models you are using. Yeah. So the simplest one, let's say if we deal with documents and text, the simplest one would be like to look at what are the words in the data. Okay, yeah, that's the basic one, because our textual data is actually made up of many words. So we can start with by looking at what are the words that has been used in the data or in the document. Okay, so the words can be treated as token. Okay, again, remember token. One single token is a one word token. Okay, or you can improvise the interpretation of token. We can have maybe two words token. So that's where we use ngram as the token in the training steps. We can also have a more complex one, like maybe a phrase, okay, a phrase, okay, as a token. So this is how we can actually use the different variants of textual features or textual form to fit into the model. Okay, so if you see that given a sentence, if we teach the machine based on one word by one word, and if you teach a machine based on phrases, the uh, the message that the machine is going to get is actually different. Okay, if you are teaching it one word, then it's going to actually capture one word at a time. Yeah, of course there are recently there are more advanced model, like from one word to another, we can also let the machine capture the sequence. Okay, yeah, that will be the sequence to sequence model, yeah, in the deep learning. Okay. So there are many different type of algorithms that we can use to try to model the input. And over here, the input will be text. So in general, because today we are going to look at machine learning, so in a very broad category, we have the first group, which is unsupervised. Okay, the unsupervised machine learning, or the second one will be the supervised one. Okay, but in between that, there's also other variants like semi-supervised. Yeah. So if you look at the unsupervised, it means that our data, we just need to fit in the data to the algorithms, and then that algorithms will try to discover a certain patterns, okay, from the data. Okay. So for unsupervised, the difference between unsupervised and the supervised one is unsupervised method, it does not need the data to be labeled, okay, at the first place, okay, for the learning. Okay. So if you give the okay, let's say we give the input to the machine, okay, some data like this, okay, then we have stars, okay, some stars, and maybe some triangle. Yeah. Okay. So what the machine is going to do is try to look for a certain pattern. Okay. One way to look for the pattern is, let's say if you are looking at documents, we can actually analyze whether a document is similar to another or not. Okay. So let's say if you have this square document and this stars document, one way to measure whether the documents can be grouped together is by the similarity. Okay. So if this is not similar, there should be a larger distance between these two. Okay. If this is similar, perhaps it can, yeah, there can be a shorter distance within this group of documents. Okay. So that is there is some similarity measure that can be used, okay, to analyze these two documents. Okay, so after we get the, okay, let's say we get this output, okay, we get this output. So we can actually group them, okay? So we will get certain groups of the documents or text. Yeah. So we will end up with a few clusters. So this is the unsupervised method. Okay, so for example, here maybe you get group C1. Okay, in the end you get C1, C2, okay, C3. You get 3 classes. Although the input to the unsupervised learning is not labeled, but actually at the end of the day, if we want to measure the performance, okay, whether this particular document has been actually grouped correctly or not, we still need some kind of label, okay, or some kind of measure annotations, at least to tell us that this is actually the correct one. Okay, so without the label also, it's very hard to tell, yeah, whether we are not able to measure, okay, whether it's grouped correctly or not. Yeah. So again lah, actually initially, let's say these are the maybe news article. Let's if you have political news, okay. Okay. Then we have sports news. Let's say we have initially we have three category of news. And okay, let's say another one, okay, is the news about entertainment. Okay, so you have these 3 groups. So let's say, okay, so you will need to actually label it, okay, so that we know that it is actually belongs to this. And for unsupervised learning is the label is not for the clustering purpose, but it's for the measuring. Okay, so we still need the label for us to measure. Okay, let's say you want to measure the accuracy. Okay, yeah, at the end. So you still need some label lah. Okay, yeah. So yeah. Okay, for me, do I need to delete the label in my data if I want to test my prediction? Yeah. So yeah, this is a good question. So let's say, okay, let me see. At the first place, you got a set of label data. Okay, so I'm going to, let's say, make this is a perfect answer. Okay, I'm going to label this like this. Okay, so initially, if you have this on the left, okay, we already have a set of data. The data has a label, like political news, or then sport news, entertainment news. So when you want to test the unsupervised method, right? The one you use for okay, yeah, training and testing both, okay, depends on how you're going to measure later, but the one you're going to fit in, you have to actually remove the label. That means you're going to take all the squares, the triangle and the stars, and make them similar, so they are all going to jumble together lah. Yeah, and then you take this whole set, and once you take this whole set, okay, out, we just make them equal, okay? So we have no idea what is the label. Yeah. So after that, you are going to use the unsupervised machine learning method, and the method will try to give you this output. Okay, so this is the best scenario. I think this is the, yeah, because it's all, let's say, yeah, it's all correct lah. Okay, in the end of the day, the unsupervised output give you 3 clusters nicely. It's able to differentiate. So it give you 3 clusters, but it will not give you the label name. Okay, it will just give you that 3 cluster. So it give you this 3 cluster, but it's good enough. Yeah, because it's actually matched to the original label class. Okay, yeah. So another step in unsupervised is normally, after you get let's say you get the C1, C2, C3, there will be one more step where you have to actually determine, okay, you can actually determine the label lah. Okay, what is this group about? Okay, yeah, so that will be another step where you can maybe try to look for some, let's say, popular keywords to detect whether if this one, a lot of words, maybe the about sports, sports happening used in this article. So you can use try to use like maybe the word frequency method, yes, to pick a good a good label to label back the category. Yeah, because here we are just going to get the groups only. Yeah, we don't have the labels. So that's one more step here. So this is the unsupervised one. Yeah. But once we know this method is good, right? The advantage is in the future. Okay, let's say we know that okay, our this step is actually very robust. Okay, it actually can help us to group nicely. So in the future, when our data is not labeled, we are still able to use this to help us to at least group them together at the first place. Yeah, it can be a first layer of labeling lah. Yeah, first layer of detecting the group so that we can get some initial label. Because in many domain, a label data is an issue lah. Yeah, because when you want to label data, if you want to label the data, you actually need input from people, experts. Yeah, unless you go for the social media, yeah, where we just take whatever label that the people give us. Yeah. Okay. So let's take a look at the second set. Okay, the second set will be the supervised learning or supervised machine learning. Okay, so for supervised type of algorithms, we will need to input together a particular document with together with the target lah, or here normally when you do programming, you will tend to see y. Okay, they use this y, x and y. X is for your features, and then y is for your target. Okay, or your label. Here means a label or class. Okay. Yeah. So you need to actually define the outcome for each of the documents, or in another word, observations. Okay, so for every document, you will need to know what is the label, whether it's positive or negative, true or false, good or bad. Okay, yeah. Okay. So the result of the algorithms after you train and then you applied it, it's not a cluster, but it will directly give you a prediction, okay, or classification. So it will tell you, let's say, if your y, okay, if your y you have maybe positive or negative, okay, or sometimes in another domain, let's say game recommendation domain, yeah, you can have okay, recommended or not recommended. Okay, yeah, to play a game, or maybe to watch a movie also, recommended or not recommended to watch a series. Yeah. So there are these outcome like this. It will supposed to tell you whether it's this or that. Okay. But there are two types. Okay, two types of possible outcome. Okay, so I will explain it a short while. Okay, so the training part. Okay, the training part, you will need to have the data. Okay, so this is, let's say, this is one document. We call it D1, maybe D2, and so forth. You're going to have many documents to to fit into the algorithm. So this is the training part. So for each D1, you need to have the information like this. So in terms of text or document classifications, this will be your target. Okay, you need to specify, okay, what Y is this? Okay, what Y is this? Okay. Okay. And what is the X? So normally our X here will be the features. Okay, you will have many features, 1, 2, 3, 4, and so forth. Okay, so you can have the word features, word number 1, word number 2, word number 3, word number 4, and many more. Okay, and your target. Okay, whether your target is, let's say, D1 is positive, D2 is negative. Okay, that is one kind of input. There's also another type of input where the target itself is not a class. Okay, it's not a class, but a value, like okay, maybe a value from 0 to 1. Okay, what is the maybe what is the score? Okay, given okay any domain where we can predict a score. Okay, maybe let's say okay, this one a very complex domain. Okay, let's say if you give an essay. Okay, noted, Fatin. Yeah, see you later. Okay. So, for example, if you want to mark an essay for primary school students, your document can be essay, okay, and then your target can be the okay. Then this will be not 0 to 1 already, maybe 0 to 100 lah. Okay, so given this essay, number 1, what is the score? Maybe this student score okay, maybe E1, this student score 86, E2 80, E3 40, and so forth. So you can use that as your training. Yeah. So we know essay has many words or many different type of phrases. So let's say we want to build a model to classify or to predict the score of the essay. Okay, so you can take this and train the model, and later when you can use to test lah. Okay, let's say you have a new essay coming in, E10. Okay, what is the score? Okay, yeah, just a scenario lah. I think, of course, grading an essay is far more than this. Yeah, if the machine can help us grade the essay, then I think the job of the teacher will be very easy. Yeah, it will help. Yeah. Okay, but the one that we are going to try later is not this one. Okay, we are going to um, have a practical one session is on the classification lah. Yeah, not the prediction. This example is the prediction. Okay, we use it as a prediction. Okay, one question, my Sarah. You can, if you want to choose the data for training and testing, yes, you can. If you have like a training data from one whole year, and then the testing is for another year, I think it should work. But again, how we are going to pick the training and testing, it also need to relate to the domain lah, to the context that you are looking at. Yeah, sometimes especially for the structured data, where a certain data is affected by the timeline. Okay, then if you choose one whole year, then it will be good, because if one whole year you can see the patterns, maybe January, February, March, it covers all the different different patterns throughout the year. Yeah. So again, I think choosing the data for training and testing goes by year, definitely is one way. But if you Sometimes it also can goes by, I'm not sure, like actually depends on the problem. It can be like week, like you train on 1 week and then what about uh the next week? Yeah. In some situation, the predictions need to actually based on the latest data or the most recent one. Then in that scenario, you will need to make sure the model is up to date. Yeah, you need to make sure the model is up to date. Yeah. So in your case, my Sarah, you mentioned that, okay, let's say now the prediction model is going to predict based on the 2018 data. Yeah. So if that is that set is suitable and the coverage is good enough, then you can go for it. Okay. So what about okay, so there are two types. Okay, so just now we talked about it. The first type is one of the type is the classifications. So where the output is a class. What is the class? It can be a positive class, negative class, or it can be multi-class. Okay, it can be multi-class. Means like a class can be politics, sports, entertainment, yeah, and so forth. Okay. Continuous prediction will be the one like the predicting uh, the score for the essay. Okay. Yeah. So it will give you it will return you a value instead of a class. So for a same problem, if you look at the same problem, like you want to predict the winner of a basketball game. Okay. So we can actually opt for classification or prediction. Okay. So for classification, we will predict whether the team is going to win or lose a game. Okay, because we know you can only have classes as the output. So you can predict, okay, this team is going to win or lose, okay, at the end of the season, maybe. Okay. Whereas for prediction, you can actually predict a score. What is the score that the team is going to get, okay, at the end of a game or at the end of the whole seasons. Yeah. Okay, so the score will be the one which is the continuous outcome. Okay, because it's going to have a range. The range can be, it depends on your training input. It can be 0 to 1, it can be 0 to 100 and so forth. Yeah. You can also predict maybe the price, okay, the price, yeah, the or the no, the price, the value of the a property or what, yeah. But then if you want to predict the scores, that will be more challenging, yeah, because it's really it's uh compared to the class one, right? Class you only have like 2 classes, 3 classes, 4 classes, but for value you are going to have a continuous range. That means you're going to have many points, yeah, which is possible that so it's harder to get it exactly accurate, but we still can measure how close is the outcome of the predictions to the correct to the original value. Okay. So okay, let me ask you one question. If a review, okay, let's say if a review has a rating, okay, we know, okay, when in review you can have like a review text or rating, right? So like you can have the stars, you can have 1 stars, 2 star, 3, 4, 5. Okay. So if you want to predict the review stars, is this a classification problem or prediction problem? If you want to predict this, what is the stars for a review? What do you think about this? Yeah. If you go to a shopping platform, we will get the stars. Yeah. So what do you think is, if you want to predict, okay, let's say now I input this review, I want to know how many stars. Yeah. So is this a classification problem or prediction problem? It looks a bit like two lah, right, in between. Yeah. Because like, okay, if you see, okay, Muna, you say classification. So that means you have 5 classes, lah, right? You are going to train one class, 2 classes, 3, 4, 5. Yeah. And for Fahmi, if you formulate the problem as a prediction problem, okay, prediction problem. So that means you are going to um, input that, okay, again, the input will be the same lah. Okay, this review 1, that review 2 and 3 and 4. And you're going to have a range like maybe from here, perhaps is from 1 to 5 lah, max. Yeah. So for me, your case, if you really apply this in using a prediction algorithm, we will also have a results. Yeah. So you may get, but just that you may get something in between. I most likely you will see something like maybe a decimal point. Yeah, something in between that. But it's also interesting to find out, I think, if you go for this class of algorithm, yeah, the classification class and the one that you can use to model the predictions, yeah, which one is actually maybe more accurate or nearer to the can give us a better accuracy or the better performance lah. Yeah. So it's I think it's a interesting problem to look at, yeah, for this the one that actually it has elements of like, looks like a bit of like continuous, and then it also is a class, can be modeled as a class. So a few more examples. I think, okay, this is one. How we can apply this, how we can apply the classifications to a real problems. Okay, this is a common problem where we need to actually label the customer support tickets. Okay, yeah, this is a problem encountered, I think, in many organizations. So when tickets come in, how can you actually classify the tickets into different category? Okay, whether it's complaint, a refund, or it has something to do with the login, so that the tickets can be passed to the support team. Okay, yeah, this is one. Okay, yeah. So if you are working in a company like this that has these problems, you can actually try to apply. Yeah, try to work on the data and build a model. Yeah, to do the automations. Okay, so how do we work on this model? Okay, so the steps is basically we need to perform training. Okay, we need to perform the training where the inputs will be will be terms. Here terms is the words. Okay, and okay, so for the terms, it can be binary lah. Let's say the terms appear or not appear. Okay, the term is there or not there. Or we can use another uh, add a little bit more on the terms analysis part, where we try to use a weighting scheme for the terms. Okay, instead of 1 or 0 to weight the terms, you can do some calculations, okay, to see how important is the terms in this whole collection. Then we can then apply, okay, the model that we have trained to new documents. So this is a very high level process. Okay. So let's take a look at one case study. Okay. So this is a real situations happen to Facebook. Okay, just to recap lah. So in Facebook, what do we see? In Facebook, we see posts, right? We see posts, and then we see the news feed. Okay, yeah. And whenever you open Facebook, it's going to suggest some news to us. Okay, so you will see the news. So normally from the one that you have viewed before, your friend, and recently a lot of advertisement. Do you realize that? I think recently my news feed is more on more on the advertisement and some other don't know from where yeah, news feed instead of my friends news yeah. So anyone still using Facebook? And do you notice like is this something that is common or just happened to me? Okay, so the purpose of the uh Facebook is like okay, the purpose of the feed lah, yeah, is to show people the relevant one lah, okay, the relevant one. But the thing is there's something called clickbait, okay, clickbait that actually is going to give you something which is not true, and it will actually uh, want to attract or want to bait you to click on it, so that it will gain some, I'm not sure, some advertisement commissions or okay, yeah. Okay. So basically, okay, how does Facebook algorithms do to look at when they try to look at this problem? Because the clickbait actually happens at the headline, okay? It doesn't actually show you the whole article. Normally, it will try to attract you. It gives you some interesting headlines, and after you click on it, only you found out that you have been cheated lah. You have been tricked. So this clickbait thingy, the trap actually, or the trick actually happens when you are reading the headline. Okay, so that is we have to go down to the problem. So once you know it happens when people are reading the headline, so what does how do we formulate these whole problems? Okay. So basically the problems actually we need to look at the headline itself, okay? Whether the headline, what is the characteristics of the headline? So is the headline going to withhold some information? Okay, whether the headline, it's trying to give you something but actually cut off one, you need to click to know more. Okay, or whether the headline is going to it has something misleading. Of course, misleading is still very subjective. We have to really learn from the misleading words. A label one, okay, or exaggerated. Exaggerated, they may use some very big words. If you see numbers also very big, like how many people missing, and then yeah, the number also like is a big numbers, or they use some words that tend to a big to be exaggerating words. Okay. So clickbait links, it says that clickbait links often have these two characteristics. Okay, so the algorithm, they will actually train on many headlines. Okay, yeah, many headlines based on these two dimensions. Because once we have to know this criteria, okay, we have to know this in order for us to label the data. Okay, so if you ask someone to label a data, let's say the person just read the clickbait, so that person actually need to judge whether this headline is withholding some information, whether it's misleading, then you can label it. Okay, so even when you want to ask someone to label, the job of the labeler or we call annotators. We need to educate them. Yeah. Otherwise, we don't know, the annotators won't know how to, they wouldn't know how to label. Okay, then they will label incorrectly. Okay, so that is the agreement, or we must first study these characteristics. Okay, so that the labeling will be correct. Okay, so example, clickbait. So these are some example, but this one are the older types, I think. Yeah. So I guess like nowadays, if you still see this, because we have learned from the mistake, once you click, you got tricked, and then you won't be tricked again, right? Yeah. So this is how our neural network works in just very similar to the machine learning model. Yeah, if you look at this 1, 2, 3, 4, 5 example, this one is these are actually the older types, right? Yeah, I think maybe now the more latest clickbait, they will have different different wordings, different headlines. So that actually that means our model need to keep on learning, need to update itself. We cannot just learn one time and then apply the this one to to the new headlines. It may not work that well anymore. So the model itself also need to keep on learning from time to time, or keep on updating in a domain like this lah. Okay. Okay. So if you click on this, and then yeah, basically it's going to disturb your viewing. Okay, you click on it, and then something pop up, games pop up. You have to close. You have to maybe sometimes you even have to refresh the whole website. Okay, especially if you have been tricked to some game site. Okay, so how to design the workflow, okay, for this kind of problems. Okay, yeah. So at first you must understand the problem well, okay, and what is your goal. So over here we know our goal is to we want to create a model that can actually identify the clickbait with a good performance. Okay. So how do we know whether the model perform well or not? Okay. Because you build a model, the model can be very bad at predicting. Then that will be even worse. Okay. Yeah. It will actually filter, or the clickbait one, maybe it miss, and then the non-clickbait it will filter, then it will make the whole thing worse. Okay, so we also need to make sure we evaluate the model, and then see what is the next steps to improve the performance of the model. Okay, if the data set coverage is not big enough, then we have to increase the coverage of the data. If maybe sometimes it's the text preprocessing step that is no good, so we have to go back to the text preprocessing step to improve the step. Okay, or sometimes it's the algorithm itself. We have chosen an algorithm which is maybe not suitable for this problem. Yeah, that's why many times you will see like one problem, one data set, data scientists often test on different class of algorithms. Okay, so there of course there are other factors that we can do the testing of the variance. Yeah, the parameter setting. Yeah, we can that this whole process actually involve a lot of testings. Okay. Okay. So once you know your problems, you know your goal, we will need the data. Okay, we will need the data. Yeah. So how big should we, should the data set be? Do you have any idea? For example, if you want to work on this problem in your company, um, how much data should you collect? or should you start off with? Any idea maybe? Yeah. How much how many data or how many headlines in this case? This one we will be using 3000 lah. Okay, we will be using 3000. Yeah, because that's the data set that is available. So we will make use of this 3000. So within that 3000, of course, because this is the one that we have, okay, let's say we only have 3000. So we need to actually divide it properly. One part used for training, another part you can use for testing. Okay. In some experiment, there's another part where they use for development purpose, okay, or validation purpose. Okay. But for this exercise, we are going to perform validation as well, but we will only have we will only divide this into two parts. Okay, one part is the training. We will be using the training itself for validation, and the other part is testing. Okay, we are going to we will divide into two parts only. So the data have to be labeled, okay, definitely have to be labeled. The label has to be correct, okay, otherwise if the label is wrong, the machine is going to learn the wrong information. So again, go back to the question of how many data is enough. Okay, if you want to start with a more testing building a solution like this, I think the first thing is looking at how many data actually available out there. If you are working on a company problem, so you can actually look at, okay, actually in my department, the real situation, what is the data size? Okay, what is the data size? Some problem may have a little bit, only a very few data. Sometimes they have few hundreds only. So you can actually, if you have few hundreds, then we just start off with that amount. Yeah. So in the future, when new data comes in, then you can actually take in the new data and to see whether you want to rebuild the model, incorporating the new data for testing. Okay. But in a situation where there's actually a lot of data out there, maybe a few millions, what you can do is, I think you can start with at least a set which is manageable and can be analyzed. That means when you start, let's say with maybe 1000 or 5000, that size itself, when it's manageable, what I mean by manageable is you are able to at least look at this set and you can actually perform some analysis. You can look at this data, okay, eyeballing a bit, browse through a little bit, see the patterns, and try to detect some, sometimes we have outliers. Yeah, so we can start with exploring on this smaller initial set first and try to build a model, yeah, based on that. Then eventually you start testing with maybe start to increase a little bit at a time and see whether that model or that algorithm or the approach that you have designed, is it stable or not? Okay, yeah. Or if you start with 1000, but suddenly the next step, okay, when you take in 50,000, the performance could be dropped. It could be dropped dramatically. Yeah, because the more data also you will have a more noise, right? Yeah. So you have to slowly build lah. Yeah, and then we have to somehow find a point lah. Yeah, where certain model may be suitable with to be built with a certain size only. Yeah, some model can be very good when you use a very large data set. Okay, so all this need I think need a very customized design pipeline to build all this to lay out all these process and solutions. But it's a interesting problems to look at. Yeah, if your organizations like or your companies departments have similar problems, yeah, it's a nice problem to look at, especially in terms of automation. Okay, so you have to separate training and testing. Okay, okay. So once you get ready the text, we will start working on the text. Okay, that's where we are going to do something similar to last week. You can perform text pre-processing. We are going to extract the words from the text. We are going to, you can perform normalizations. Yeah, you can remove stop words. You can perform lowercase. Yeah. So whichever steps that is suitable, then we have to see whether a certain pre-processing process steps that you have taken, will it affect the final performance or not? Okay. Okay, so, but today we are going to look at one additional part in the features, which is the weighted features. Yeah, here. Okay. Last week, remember our do you still remember the DTM, the matrix, document term matrix? Yeah. So previously, when we look at the work on the matrix, the entry of the cell is actually the frequency. Okay, if the word appear one time, it will appear as one in the cell. Like for example, remember the goat appear, let's say 3 times in the document, it will be recorded as 3. Okay. Today we will extend a little bit more on the weighting part. The cell will have a weight or a score. Okay, instead of the frequency. Okay, yeah. So we will be using this TF IDF formula, okay, to weight the terms. And then, okay, finally, once the textual features are ready, then we can start the training. Okay, so the training, we will need to pick an algorithm. Okay, so we will be using this algorithm, which is the regression from the GLMnet package. Okay, so later we will need to install this GLMnet package, and we will use the regressions algorithm. Okay, so inside this within this regression algorithm, there are different variants as well. Okay, there are a variant called lasso. There's another variant called reach, and another one. There's another name I forgot already. Lasso reach. Okay, we will go to that section later lah. Okay. So so the training part, you have to pick one setting, or you can experiment on a few algorithms, different type of algorithms. Okay, and then finally, once the model has been built, we will evaluate. Okay, we will evaluate. So there'll be evaluation as well. So that's the end, okay, for the overview. Okay, so let's go to this part. And you can download this first. So let me brief you through. You download this too. I'm going to give you a 10 minutes break, 10 minutes break, yeah, after the overview, so that you can open up your R Studio and refresh a little bit, okay? Yeah, you can just open up the R Studio. Okay, perhaps I give you a 15 minutes, 15 minutes break. And what I want you to do is you can open up your R Studio and then try to load the previous last week platform. Okay, you can open the projects, recent projects, simple text mining, and just go through um, the scripts again. Just take a quick look at the scripts. Okay, yeah. So while I get ready this platform as well at my end. Yeah. So the okay, that's one thing. Okay, the second thing is you can okay, I don't want this. You can also install the packages, okay, during the break. Okay, I'll let you know what package to install. Earlier slides are the same. Yeah. So install the highlighted one. Carrot, GLMnet, Matrix, and PROC. Okay? Yeah, so that's yeah, you can get this ready. Okay, yeah. So open up the RStudio, okay, download all these packages, and also take a quick look at last week scripts. All right, so I'll see you in a short while. Okay, so 10:04, give you 15 minutes to get ready the whole platform. So we continue at 10:20. Okay, we continue at 10:20. Okay, so remember, install this. Yeah, 1, 2, 3, 4. Okay, yeah, I'll leave this page here for you to refer. Okay. Okay, do you manage to install the packages already? GLMnet, Carrot. Okay, Carrot we will be using for data partitioning. Okay, the partitioning, and then GLMnet. Yeah, that's the algorithm that we'll be using for the training, the package. Okay, and this one PROC is for the one of the performance metrics. Okay, metrics is a setting that we are going to use for the to manipulate the metrics. Okay, so next one. So similarly, just check, okay? Just check whether you have actually installed the package or not. So let's go to the R. Okay. Yeah, another thing is for this project, after you install, you can create a new project for text classification. So same steps, create a new project for text classifications. So you can name it text classifications. Okay, then you get one whole folder for it. Well, similarly, some optional folders. Okay, and okay, also create one R script. Okay, one R script for text classification like this, and then save the R scripts. Okay, so all these steps are same as last week. Okay, just that this is for text classification. Okay, so I'm going to go through this. Yeah, stop here. Okay. So for your R, you need to create a new project. Okay, so you proceed with this and then go to new file, create your R scripts. So I'm going to load my existing one. Close all this. New file, R scripts. can save. So yeah, so if you have created the project folder, you will find one folder like this lah, text classification. I'm going to save it. Remember to save your scripts. There's also a file that I've shared. This one, text classification. Yeah, you can grab this. Okay, let me move on. Okay, so this is the sample. So I'm going to go through with you the sample. Okay. Yeah. Okay. For those who have installed packages and created your scripts, can you type number 1 so that I know how many are ready to start? Yeah. You just type 1 in the chat box. Okay, Anissa, Akmal, Siti, Maisara. Okay, Muna. So once you're ready with the scripts, you just type 1, okay? Okay, Aini, Afik, Aswa, Stura. So let's start with again we will load the package first. Okay, do you still remember how to load the package? Okay, so basically the first part in your script, you can allocate it for the package loading. Okay, which is okay, so you can load all, you can just type all this lah, and you can load one at a time or just load all, but I think we can do okay. Over. Okay, so basically we will start off with the TM package still partitioning TM package. Okay, and this field okay, let us load this field first. Caret TM matrix and GLMnet. Okay, so I'm going to load this 1 2 3 4. So if you forget how to run, okay, you can select a few lines to run. Okay, so that means once I do this and run, you can see down here the status. So it's going to load 4 packages. Okay, it will load 4 packages, and you can come to the lower right to check. Yeah, you should be able to see here there's a tick beside caret. This one and other packages. Okay, so that's the package loading. I think the rest I will load later. Okay. So after package loading, okay, after package loading, Okay, we will be doing preparations before the start with the late data loading and so forth. Okay, because later we will be needing two functions. One is to help us to clean text. Another one is to create the matrix. Okay, I will explain more about that in a short while. But okay, let's start with the first function. Okay, this first function actually you can create it as a function, or you can just run the or you can just perform the cleaning steps as last week. Okay, yeah, last week is like we are actually typing the steps one after another after the data loading. Okay, if you can still remember, we load the data, we view, and then we perform the cleaning. Okay, we call the text preprocessing functions in the cleaning after the data loading. Okay, so this one is just another way of you to perform a series of preprocessing by just listing them in the functions. Okay, so the advantage of creating a specific functions for preprocessing is like you can actually customize this function for a particular processing, maybe pre-processing needs. Okay, so you after that you can reuse the function again. Okay, after you create the function, you can reuse again. Okay, yeah, because perhaps you have a different pre-processing needs for different type of text. Some text you may want to normalize, some text you are not going to normalize, and so forth. Okay, some functions you can create specifically for maybe social media text. Another one could be for maybe long text. Yeah, so you can actually design the pre-processing steps accordingly, and then create different functions for different pre-processing needs. Okay, so this is just this is one. Okay, so basically, this functions has how many lines? 1, 2, 3, 4. It has four. It's going to have perform four types of pre-processing: to lowercase, remove stop words, general one only, remove punctuation, and strip white spaces. Okay, yeah, I think strip white spaces is not counted. Only three lah. Okay, 1, 2, 3. Yeah, it doesn't do the normalization. Can you guess why we skip normalization for this data set? Okay, you can think a bit about it first. Okay, yeah. So that normally there's a purpose when we skip a certain step. Okay, so basically, okay, so we have three types of pre-processing. So the function is going to take in your text. Okay, after repetitively performing this, it's going to return X, return your text. And the name of the function is clean text. Okay, very simple one. Okay, so let's create this first. Okay, let's create this. Okay. So you can hide or you can grab from here. Okay, the preliminary preparation. So when you want to create the functions, you have to make sure you select from this first and until the end. Okay, and you click run. So to check whether the function has been created, okay, you can go to your this environment here, okay, and scroll down. Yeah, you will see this function listed under this this section. Yeah, clean text. Okay, so you need to find this okay, you need to find this. Clean text should appear over here. That means the function already created. We can use it later. I give you a moment to do this. Create the function for plain text. After that, we will proceed to create another function. Okay, we have one more before we start. Why is your environment empty? Okay. A quick one. Okay. Did you? Okay. Have you selected this one from the? Have you run this? Okay, you need to select from the first line and until 36, and then click run. Okay. And okay, let me see. You should. Okay, environment tab. You scroll down. Can you see this one? Functions, plain text. No. It should appear. What about others? Do you get the functions here? Just but I don't think that will affect. Afi, can you check whether you have created the projects? But normally it should appear as well. Yeah, just checking. You didn't run the. No need to run the get working directory. Yeah, Anisa. Yeah. Actually, run get working directory just for us to check only what is the path of the project. Yeah. You still using last week's project? Oh, okay. So you use last week project, and it should appear. It should appear right here. Do you want to share screen? I take a look. Okay. If you want to troubleshoot, I can just take a quick look. You can share your screen. So basically, I think last week project also the same, but you need better create a new scripts. Okay. Okay, wait a minute. I zoom a bit. Yeah, even your last week. Wait. Even the last week environment is not there. The environment is empty. Okay, you have loaded a project. You have just a moment. Check the. You have clicked. Okay, can you do this? Can you save this? Save the script. Yeah, just save the script. Just save first. I'm not sure that a few lines got issues. You just save. Maybe can you scroll up? Oh, you combine this one. Combine also shouldn't be an issue. Maybe Afiq, can you create a new script better? Yeah, you create a new script. Otherwise, it could be very messy to this one. Okay, what we can do is create because your current environment is empty. Can you close the project and load again? Because I want to see whether it's loading or maybe last week we didn't save. Okay, can you close the project, the RStudio, just close and load again? Oh, you auto loaded, okay, never mind. Okay, so you can close this search one. You can close this tab. Yeah, close. You go to Untitled. Environment is empty. Okay. Can you just packages? Okay, can you click on the packages tab down there, lower right? I just want to make sure you have done the. Do you have like a caret, CARET? Can you check? Okay, it's not loaded yet. Okay, maybe. Okay. Yeah. We do this again. Yeah. Okay, can you save? You save the file first. Just save the file with a name. All right. Okay, can you execute this first? Okay, now you have the tick. Okay, second step. Yeah, we test with the functions. Okay, the second step. Yeah, just the first part only. Okay, it's there already on your right. Okay, remember to save lah. Yeah, it's there. Yeah. Okay, I'm going to share my screen. So this is the okay. Remember to create a new script for others. Don't reuse yesterday last week one. Yeah. So basically, if you create a new project, the good thing is you can actually because sometimes we will use some same naming. Yeah. If you use the same project, then they will override. Yeah. If you have happen to have the project with no, you happen to have like objects with the same name, it will override from the previous. It will override the previous one. So this is one. Let me go back to this. Okay, the second functions. This one looks very complicated. Not a bit. Looks very complicated. But okay, I will explain. What is the purpose? Okay. This function is called the matrix function. So if you just take a quick look inside this function, you will actually see what is inside is going to load the your this one, the training collections, and then it's going to create a DTM for you. Okay. Yeah. So it's going to create the DTM here. You see here, load the DTM, create the DTM, and call the DTM as a matrix. So the purpose of this matrix is first it create the DTM, and then it also set the weighting lah. You can set like TF or TF-IDF in the input, and it so once we input the, let's say, training text, training collections, it will create a DTM based on our training text. Okay, same something like the review text that we use. Okay, so it create a DTM based on the training text. So inside the training text, there are many words. Okay, so the words that we have actually been cleaned and everything, we used to create the word vectors. Okay, we used to create the word vectors in the matrix. So what's going to happen is during when we want to apply the model, okay, let's say you create the DTM, we train the model. When we want to apply this model that we have trained, we won't be using our training text, right? We will be using new text, testing text. Okay. So the testing text, when testing text comes in, the testing text will have its own words, right? Yeah. Some of the words may appear in training. Some of the words may be new words. Okay. So what's going to happen here is, if we want to use the model to do a prediction for the testing text, we have to actually, when the testing text come in, we have to align the words, make sure it only, we can only actually calculate, okay, use those terms that appear in the training before. Okay. So this is the part where the alignment happen. Okay. So when testing text come in, it's going to refer to the DTM of the training data. Okay. So the DTM of the training data has a certain words. So it will actually map the testing text to that set of words. Okay, so it's going to map to that set of words. Yeah. New unseen words, we cannot do anything because for this kind of this approach. So because we can only do predictions or classifications based on the words that we have learned. Okay, based on the machine, the words that machine has learned. Okay, yeah. So this is the part. You create the function first. When you use it later, I will explain again. But you have to be very careful because it's very long. Yeah. Yeah. So this is a bit of explanations. When a model initially you have 1,000 terms, okay, represented. So any new documents come in, it must be mapped to these 1,000 terms. Okay. So that is when new document come in, we cannot just new a DTM, because if you just create a new DTM, it will have a totally new set of terms. So what it's going to do is it's going to map to the old DTM. Okay. Okay, so this is the second functions. Okay, it's kind of long, so you have to make sure you add, make sure you cut and paste from the first to the last line. Okay. So you select and run. Yeah. After that, you will see another functions created here, match.matrix. Okay, so another one, yeah, second one, two functions. Okay, two functions. So if you have some issues with the functions creation, you can let me know at the chat box. Okay. So after that, we are going to proceed to the load data. Okay. The data set is in the CSV file, the 3000 headline cs.csv. So you copy the CSV file and then you can put in the path lah. I put in the data folder. So the first step is we just want to load the CSV. Okay. You just read.csv, use the function read.csv, specify the correct path, and then load it into the headlines data frame. Okay. You see the path here, I just put a relative path because data folder is in my project folder. Okay, so if it's like this, if the folder, you put it, you can specify the folder in this way lah. Okay, a relative path. That means you do not need to type a full path. Okay. So view your headlines. Okay, it should look like this. Let's load the data. So remember to place your CSV file, okay, in the folder. So the CSV file grab from here, all 3K headlines. Load data. Okay, you can view specific parts. Okay, let me. So I'm going to run line 78. Run. Once you run, you will find the data frame here. Okay. Yeah, this one at your environment. So if you click on it, okay, if you click on it, it's same as you're calling the function view headlines. So you click on it. This is the data, which is exactly the same as your CSV file. There are 4 columns, headlines. Okay, so these are the headlines. Okay, see only headlines are one sentence only. So this one is a short text. Okay. After that, you got the let me view again. So the second column is the URL. We are not going to use the URL and site column. And the last column is why. Why is your target label? You can see here those labeled as 1 is the fake the clickbait. Okay, the clickbait, which is the fake one. The 10 is the genuine one, the genuine headline. Yeah, so this one is the genuine 10. Okay, but you see how this data set is labeled is based on the how, if you see this label it's based on the site. If a particular headline is from this kind of website, Daily Buzz, Activist Post, is treated as clickbait. Okay, so this site actually they have been already classified as a clickbait, and they use this to actually grab the to determine okay, whether this is a clickbait or non-clickbait. You can see from this side. But after you train the model, you can actually, without knowing this site, you can any new clickbait, we don't have to know the site. You can actually predict. Yeah, for this case, Anisa, you asked a good question, because for this case, right, when the Y is labeled, is based on the source of the website. Okay. But the thing is like this. Okay. If you, okay, now is the question, do you need a machine learning model or not? Okay, do you need to train a machine learning model if you already know the site is a clickbait? Yeah, if if it's very clear-cut problem, like we already know, like this news already come on, definitely BuzzFeed is a clickbait, 21st century is a clickbait lah. If this is the how it works in the company or what, then actually we no need to train a machine learning model, because once you detect, okay, this is the post come from here, definitely we can use the rule base to 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 determine lah. Okay, these are the list of the banned website, already banned one blacklisted. These are the one clickbait. Okay, yeah. So that is the rule base. If for problem like a very straightforward problem lah. Okay, but in this for this data set, although we know that the way they label is very obvious, right? The way they label this website all is actually labeled as a clickbait site. Okay, why? The why is one. Okay. But the thing is, if we once we build the model, we can actually omit this URL and sites. Okay, because they could be new site that actually, you know, they are forwarding one. There could be many new sites coming out lah. Yeah, just like another site can also share something from the BuzzFeed, right? People keep on sharing. Yeah. So without this, later we can actually, based on the headlines, we can do the prediction. Okay. Yeah. So here you got 3,000 data. So it's nicely, actually this data set is very balanced, because you have 1,500 1 and 1,500 0. Okay, half. Okay. Yeah, it's a balanced data. But what our purpose is we want to pick up clues from the words in the headline. You see, when people use the words like shocking, maybe, you know, all these words basically all these words, we will actually pass to the machine to learn. Yeah, do the learning. So this is the data set. Okay, next step. So if you want to view a certain part of the data set, you can try out this code lah. Views a certain row and a certain column. Okay. So after you do the okay, after you load the data, now we want to split into training and testing. Okay, yeah. So we are going to split into two sets. Okay. In some of the machine learning pipeline, the test and training is auto split. Okay, they automatically, okay, here we are going to automatically split, but we will put aside these two. Okay, but some pipeline, every time you run, it's going to have a different training and testing. Yeah, so that is another setting lah. There are pros and cons actually, because if you keep the same testing, we can keep on improving the training, keep on improving the model based on the training text, and then use back the same testing to test the model. That is more fair lah. Okay, yeah. How to check the count? Why count by 0? This one here. Oh, okay. Here I think you need to use a formula, but I can't remember for now. You can just sum the column one where it is y. Yeah, this one you can need to look up the what is the code for it. Can, if you want to automatically count, yeah, sum the column where it's equal y lah. Yeah. Okay. So okay, let's continue again a bit on the training and testing. Okay, so now let's decide how you want to split this data set. Okay, how you want to split. So in general, if you read a research paper, they will have different split. Sometimes they will have like 80-20, 70-30, 60-40. Okay, so I'm going to continue with 50-50. Okay, so when I set 50, I need to set 0.5 for 50-50. If you want a larger, okay, let's say if you want a larger training, okay, because we are going to assign the first part to the training, you can set 0.6, 0.7, yeah, different size. I think maybe each of us can try a slightly different split. I will take 50-50. Some of you maybe can try 0.8, 0.9, 0.7. So later we can counter check the results. If you take more training tags, we see what happens. But my testing set is going to be larger lah. Okay, yeah. Actually, it's not that fair. Also, if I compare, normally if you want to compare the performance, I have to fix the testing set. Let's say I have 100 testing and 900 training. I will need to work on the same training tags and then try a different size from my own split. But it's okay. I think we just roughly try to estimate only. Yeah. So each of us can use the same different ratio. So we will use this one, the carrot package, create data partitions. How we are going to partition it is based on the Y column. You see here, Y column, yeah, in your headline data frame. And then, okay, we will assign that part to the one part to train. Okay. Then there's also another part. So when you do this, right? When you do this, what it's going to give you is the randomly selected rows, because we got 3,000 rows. So this function actually is going to pick the 1,500. Okay, yeah, 1,500 from each of the class. Now you got 1 and 0, so it's going to pick 1,500 from both of this, and it's going to return the numbers only, the index, which row is it that has been randomly sampled. Okay, so you're going to get the index. Okay, so once you get the index, we can split. Okay, so just use the data frame, the one with the training index. Yeah, so you just create a subset lah. And then this one is the minus one, everything complement, we assign as test. Okay, so now you got two sets. So let's do this. Yeah. So after this step, actually we are going to have a different data set. Each of us are going to working on a slightly different split. Okay, yeah. So this is the create the train and test. This line 92. Okay, I'm going to split. I'm going to randomly sample first. I'm not splitting. Yeah, sample the data first. So okay, if you run line 92, okay, you will actually get a index. Yeah, this one from here. Okay, this one. So you will get these numbers. These are the sample data for training. Okay, so if you see the entries here, 1,500, because I set 0.5. So I got my 1500 index already. Okay, next step, I'm going to use this index, okay, to create my training. So this one just a subset of the data frame. So if I run this, I will get train.headline. Okay, let me do the test also. The balance, okay, you take the complement, the minus, okay, yeah, of the index will be the test. Okay, so you run again. So now I got two sets, train.headline, test.headline. So you can take a look at these two sets here. So you can also click, okay, go to find your train.headlines. Okay, you can click on it. So these are the selected training tags. So I got 4, 7, 10, and so forth. And my test data put aside. Where's my test? Okay, test.headlines. Okay, another 1005. Okay, yeah. So now I got two sets already. One is for training, and this one is for testing. Okay, training and testing. Yeah. So both of my training and testing will have the you see the ones and zeros. Yeah, it has been sampled. Yeah, from the original the raw data. Okay. So you got two sets here. Okay, can I just get a quick feedback on what is the ratio that you have chosen? You can type at the chat box. What is the ratio that you have actually selected for the split? Okay, there are a few 0.6. Anyone taken a larger set, larger training set? Okay, so now we get two sets, training, testing. Testing, we are going to put aside first. So our model, we will use the training data to do the training. Okay, anybody use a different split than the 0.6? Yeah, I think some of you can go for like 0.8 or 0.9 or so. Error in data, create data partitions. Create data partitions. Afiq, have you loaded the package Carrot? This one? Yeah, this package. You see the lower right in my screen? It cannot find this function. Most likely you haven't loaded this because it need to use this package. Yeah, this one. Afiq, can you try 0.8 maybe instead of 0.5? Can already? Okay. Actually, even if you set 0.5, your training text will be different from mine because the sampling is done randomly. Okay, yeah. So we will have a different set from now on. Okay. All right, can already, yeah? Yeah. Okay, next. Okay, so now we can proceed to the text preprocessing. Okay, so we are going to start working on our training text. Okay, so the next step will be cleaning lah. Okay, the cleaning. So we will be using the clean text function. Yeah, so we will be using this clean text function that you have created. And what we are going to clean is the headline column only, because later we'll be using the headline column to train the DTM. Okay, so we will pass in the headline column from this train.headline data frame. Okay, so the output will be clean.train. Okay, so this is one thing. You can view the output, okay, after cleaning. How does it look like? So this is before, the left one. This is before, and this one is after. So we proceed to clean the text. Cleaning. Okay, the cleaning part will be here. Okay, yeah. So if you clean, yeah, just because we want to clean this train.headline, this column. Okay, we are going to clean this. So let's run 103. So you can view lines. Yeah, so this is the clean text data. If you want to add other cleaning step, you can also do that. Yeah. And also if you want to do other like noise removal, you can do that as well. You can see that we have applied actually lowercase to the words, but we didn't normalize. Okay, we didn't normalize. Okay, any idea why we skip the normalization part? Anybody want to guess why do we skip the normalization part for these headlines? Yeah, this is our function. We didn't remove words, no, numbers as well. Okay, Mona, you said we need all words. Yep, basically yes. And especially we want to keep the words in the original form, because you can see like words like you see struggling, adapted. We want to keep all these original form of the how the word is being used. Okay, mostly I think assuming that if adapted, it means something. It could actually give a better meaning, okay, in terms of the semantics, or yeah, when used in headlines. Yeah. So for example, like here, maybe what happened, all these are very important because we want to keep all the word variants, like shocking. Okay, yeah, so you have shocking, you have shock. We are going to keep them as the original form. So okay, so now we are ready to represent the text. Okay, so with the cleaning done, we want to create the DTM. Okay, where's DTM? Okay, so again, we will create the document term matrix, but this time we will use the match.matrix functions. Okay, next one. Just a moment. DTM. Okay. Hanim not available. That means okay, check back this one. Okay, let's trace your train dot headline first because we want to make sure you have this. Do you have your train dot headline? Can you find your train dot headlines?
I
This one? Yeah, you have this?
yeah, I have.
You have train dot headlines.
Yep.
Okay. So once you have train dot headlines, you are going to run the function clean text. You have clean text, right? Do you have clean text function?
Yep.
Where's my function? Yeah, this one.
Yep.
Got that? This clean text function.
Yeah, I have. Text.
Have you loaded TM package? I'm not sure whether the cleaning is done properly or not. Have you loaded TM package?
Yeah, loaded.
Because loaded.
Loaded.
You want to share screen? Just take a quick look, yeah, before we go to the DTN. Because yours, I think there's no word inside. Yeah.
Okay. This one. Yeah, I have TM. I have clean text.
Okay. Yeah, the clean dot train is empty. Uh, just a moment, take a look. You got train dot headlines, right?
Clean dot headline. Yeah, this one I got.
Oh, I think it. You see your headlines
Oh.
column. Yeah, there's a weird character in there. I don't know.
Oh.
Hmm. Just now when you load the headline, is it there already? Headlines. Can you click on your headlines data frame? Just the headline, the original one.
This one? No.
No,
This
the
one.
headline. Yes.
Oh, I got I something.
Where did it come from? The I something.
Want me to check? Wait, let me check my data set.
You didn't make any changes, right, to the data
No,
set?
no.
Yeah, that's why
Wait.
should be the
Wait. Yeah, I did not change my
yeah.
this headline.
Hmm. But seems that when you read, it's reading it as another character.
So I need.
Mm,
Is there anything that I need to change?
Actually, no need to change anything. Yeah, the probably okay. Can we just go back to look at your code?
This one.
Okay. Read. Okay, now you are reading. Okay, reading CSV. Read dot CSV. Your headlines. Mm, can you see what is the additional character in the
See in
headlines?
where? In the.
In your train dot headlines, yeah. What is it? It's a bit weird one, right?
How to see?
Oh, cannot. Okay, I think one way is to let me see if you can load it. When you load the CSV, maybe you have to set some data encoding setting. Another way is perhaps can you go to edit the CSV file at your end?
Edit the CSV file. Wait.
You edit the CSV
Wait, let me
file.
stop. Let me stop first. Wait.
Sure.
I open the CSV file. Okay, wait, let me share back. Yeah, this one. This is my CSV file.
Okay, just a moment. You have to maybe you have to import the. You have to save as the UDF8. I'm not sure. You can try.
Save as. Sorry.
Okay. Probably the headline. Maybe you delete and type back and see. You just
This
delete.
one. I
Delete.
delete.
Yeah.
And then I take
Type
headline
again.
like this.
Sure you work the. All right.
And I save.
Okay. Wait. Yeah. You save. Because all these characters are not sure whether. Okay. You can try again. Otherwise, I need to look for the. When you load it, you need to
So that means I
set another set. You
I'll
load
start from
again.
here. I start
Yeah.
everything from
16.
here
Yeah.
until
Just
cleaning. Huh?
just one at a time because we want to see headline got it right or not.
Okay, this one, yeah.
67. Yeah.
Okay. I run. What to? I run this one. So my
And then view
headlines.
again.
Yeah, still got this one.
Still got this one, huh? Another way is to anybody else get this these characters? Any others? Because this is the first time also, right? So, okay, we ask others and see. Okay, now wait, go CSV. Another thing is can you give me a moment to check
Okay.
how to do this, okay? Yeah.
Okay. All right.
Okay, I think just can you try to add one more setting when you load the CSV? You just put the space encoding equals. Okay, I type in the chat box.
Okay.
After the read CSV, right? And then you have your path. You put a comma. Just now you read your CSV, read the CSV at the end of the line. Yeah, you after the you put a comma. I want to add one more
I comma here.
parameter. Comma before the bracket.
Comma before the bracket.
Yeah, inside. Yeah, comma space. Then you type this encoding equals.
Oh, I cannot see. Wait, let me.
Wait, I put in the chat box. I type in the chat box for you.
Oh yeah. Wait, I cannot see the chat box now. Can I unshare first? Yeah. Because
You try out first, okay? You try and see. If cannot, then we'll try to troubleshoot it again. Okay, you try.
okay, now after I put that, my headlines now become x.u.feff.headline.
X.u.
I share back.
Oh, okay.
become something like this.
It changed to something else lah. That means it
Yeah.
has actually
Can you see?
I try to
It
be
become x dot u dot f
wait
e.
a minute I think you need to reshare because I have taken over the share screen.
Oh.
But I can understand. You give me a while to see how to solve this.
Okay. Yeah.
Another way
So,
would be we save the CSV. Yeah, that's another way. Yeah, I got it.
okay.
Is it affecting any other character in the text? Maybe I just think maybe your text also some other character could be affected.
Sure.
But inside the column looks okay, Okay.
Seems okay. Yeah, looks okay.
Unless unless alternatively you just enter this code, but not nice lah in the cleaning. The all these interpretations are this x dot u something something something. You add in the
Okay, I understand.
you
Meaning
add down there, yeah.
I
That's
need
one
to add
one
over
bad
here.
solution. Yeah.
So, what is it? This one headlines that mean x something x dot blah blah blah.
Yeah.
Okay.
But this is the
Xu dot fe
not supposed to do this lah. But we can try first lah.
xu f sorry x x dot u dot eff dot headline something like this. Okay, never mind. We try. Just now.
Oh, then you okay
I need
dot
to
Is there a dot after that?
dot yes.
Oh.
Something like this. Yeah, dot.
Oh.
So just now I view headlines. So I need to run all of these.
No need, just that line only. Just line 86.
This one. Okay, run.
Then 90. Oh, still empty.
Okay,
Cannot.
no.
Still no. Okay, can you screen capture this and paste at the Padlet? Later
Okay.
after a few steps I'll come back to this one again.
Okay.
Okay?
Sure. Stop sharing.
Mm. Oh, but this is the first time I see this issue. Why is it like this? Okay. What about the rest? The rest I think okay, right? Okay, we move on a little bit first, and then we try to see how to solve that problem. If anybody know how to solve that, also you can share with this Hanim. Okay. Okay. So let's proceed to create the DTM. Okay, we create the DTM. Oh yeah, Mona said read.csv encoding issues. Read. Okay, you can try this as well. Read.
Instead of read, you can use.
You use the another library. Read dr, and then when you read your CSV up here, yeah. So you use the other function to read the data frame. Okay. Yeah, you try out Mona's suggestion. Okay. So the rest, we proceed to create the DTM, which is, okay, we are going to use the match.matrix functions. Okay, Then we will specify that we want to use the TF-IDF term weighting. Okay, so next one. Yeah, so this is how we are going to specify the weighting. We have to follow the naming schemes. Okay, in the TM package. So we have to input the clean.train. Okay, so like just now her name, she cannot input for this step because there's no words. But what we need to input here are those rows yeah, of the clean text, and use all the words from the clean.train to create the DTM. Okay, okay, so this one. So you can also view your DTM. The summary will look like this. You will get the total number of documents, your training set, and your terms. Okay. So compared to last week, this week we are dealing with a far bigger set of terms, 5,000 over. Okay. But it depends on your split. You will get more, maybe if your training text is larger. Okay. And yeah, if you take note, this one, sparsity. Last week, our sparsity is like 84%. And then after that, 70 something. Today is 100%, but it is actually not exactly 100%. It's like 99.99 something. Yeah, it has been rounded up. You can recalculate using these numbers. Okay, you will have these numbers. The sparsity is basically close to 100%. The reason is many cells are actually zero, and there are many terms which is like occur maybe one time only. Yeah, it's close to 100. Yeah, you can recalculate lah. This is the non-sparse entry. Okay, you will most likely you will get 99 point something. Okay, so you can inspect the DTM. Okay, you can inspect the DTM, and what you're going to see is something like this. Most of the cell will be zero. If you're lucky, then we can get to see one cell with the TF-IDF term weighting score, like this one. So Jerry, the term has this weight based on the TF-IDF calculations. So TF-IDF, the scoring is it's using two factors. One is the term frequency. Okay, term frequency times the inverse of document frequency. So inverse document frequency is not okay. DF is how many documents has the terms. Okay, like our total document is 1,500. So if all the document has Jerry, the DF will be 1,500. But this is going to take the inverse one. That means inverse means if the terms appear in lesser document is better. Okay, but then the weighting is not just TF times IDF, but here they are taking, I think normally we take the log log TF IDF, the log value. So this is the output. Okay, you can try to create the DTM, then we check. Yeah, we'll check the number of terms. Okay. Okay, let's come here. So now you will use the match.matrix functions. Yeah, match.matrix. Here. Okay, remember this one? Okay, run 113. So you will find your DTM at the environment here. And you can inspect. Okay, you can inspect. Okay, let's inspect. Okay, run. So if you just inspect your DTM, it will show you a sample. So here my sample all actually the one with the weight one is not in the sample. Yeah. So okay, the total term that I have is 4997 here. 4997. Okay. Even if you choose the same trainings and testing ratio, you will get the different number of terms. Can you share the number of terms that you have over here in your DTM? Okay, so for example, yeah, Muna, you has a bigger number of bigger size. Just now you choose 0.6, right? So definitely more terms are included in the training process. Yeah. If you want to recalculate the sparsity, you can just calculate um the this one, the sparse entries over the total entries. Okay. Yeah. So Mastura, you got yeah, a few terms more because your training text is different. Okay, Mastura, you okay, wait. No, that's Afiq. Okay, Afiq. Mastura, you got many more, yeah, because yours is 0.8. Okay. Afiq, you use the same setting as mine, more or less the same then. Lisa, okay. Hanim, how's your this one? Okay, the rest I think you can just investigate.
Okay, I tried just now, but
Yeah.
I cannot use that function actually. But I tried to rerun again using the one that you shared earlier, putting the encoding UTF dot dash 8.
Huh.
I was able to run it, but for my, yeah, I need to change my column name instead of headline. I need to put that one, the x dot u dot
Uh-huh.
feff dot headline. Then I'm able to run it.
Oh, you're able to run it. Okay.
Yeah, but it will
Or why
have
not you?
the. Uh,
Or you what you can do is why not you change the headline call name into just head only,
Head.
or
Oh, okay.
that's save as okay. You see whether how to save as just a quick exploration. Any other version that we can save? Where is it? Okay, sorry, not here. This one, right? Just clear everything from there's one eraser button. Yeah, just clear everything in the cell. Remove any. Probably you can try clear the cell and then type again headline. That's one option also. Yeah.
okay.
Yeah, this one use eraser this one to clear everything. Some
Okay.
okay, wait, Mona. Another one is you can save as, but I think our format is already CSV UTF dash 8. Any other format that you can try? This is just the CSV format. They can play around with this lah. Save into another CSV format. Only a few CSV format. We already taking this format. Yeah, I think a few options are you can try this. Save as another format, or try to erase this. Use the eraser
Clear all
and
right.
type again. Yes, or just change the name. If you change the name, I doubt like they will still keep the funny numbers, funny characters there. Yeah, you try again and see. Yeah, testing a bit. So all this, sometimes it happens. Okay. To get different results, I should adjust the 0.5 in train. I think if you want to try a different partition lah, if you want to change the partition only, let's say now you think that maybe I use 50% is too little, 1500 is too little, I want to use a bigger training set, then you can change that. Okay. Once you already run, yes, you can change the partition. Yeah, you can change the partition. You change when you change the partition, that means you can either you can overwrite the current training set, or you can just rename it. Means that you are going to take another sample. You are going to create like maybe train number 2 or what, right? You can name it differently just to keep track. Yeah, it is very flexible. I like this approach because like here you really have full control. You really can see what is your training text. It's not like a black box. Yeah. You really can see what is your testing data. So you can play around with this. Yeah. If you take a different split, but the thing that you cannot control is the sampling part lah. Yeah, you will auto sample. Unless you yeah, you want to keep this also okay. Yeah, some people they prepare the training and testing at the CSV level. Yeah. So you can directly load one training CSV or load one testing CSV. That also will work. But for this approach, it's like if you have a very large file, it can help you split It can help you split the text in a fairer manner because it's random. Yeah. Okay. So where are we? Okay, you already got your DTM. If I inspect, yeah, I still cannot see the one with the numbers. Maybe some of you have the words. Okay, I still can't see. It should be in somewhere in there because it's so big. Yeah, the matrix itself is very big. Okay, next. There's a step that we will perform to the DTM, which is basically this one is to save some space only. Okay, so this one is like just now our DTM is recording a lot of these numbers like zeros and of course the weight. This step will help us to minimize make the size of the matrix smaller. Just what it does is to actually drop the zero. Okay, because it's keeping zero, we are not using the zero as well, so it's not storing the zero. Okay, yeah. So this is the step where we use the matrix package, the matrix functions to when you set sparse equals true, what it will do to the matrix is it will drop the zero. Okay. And if you view again, inspect the matrix again, you will see that the zero actually is there's no information there already. Okay. That's the dropping the zeros. After that, we will start training already. The next step is to start training. Okay, but let's do the continue with this step first before we move on to the training. Okay, so convert DTM into the a sparse matrix. Okay. your DTM I125, okay, and then 128. Drop the 0. If you look at the sample, yeah. So the 0, basically the information is gone, okay? Yeah. This is to, okay, DIM is the dimension. It shows you the dimension of the matrix. Still the same, okay? The dimension still the same, but it's just dropping the information. So the next step, we are going to build the model now. Okay, yeah. The package is GLNet. Okay. So what we are going to do is we will use the regressions algorithm, and we will also use one features called this cross validation. Okay. So cross validations, the purpose is to, when you build the model, okay, because now we are going to build the model using our training text. Okay. So within that training text itself, cross-validation process, it will further split the training text into one part that it's going to train, and the other part is going to validate internally. Okay, yeah. So this is a iterative process lah. It's going to shuffle through a few groups of data, and then it's trying to detect a parameter that is actually better. Okay, yeah, we will see it from the output later. It will actually we can see a graph when it's repeating the process. You are going to actually it will internally, like, it will adjust the parameters, and then suggest a better settings for you, and also suggest a better settings of a better set of the features to be used in the model. Okay, so what it does is within your training data, it's going to split. Okay, so you can actually set how many partitions that you want, or how many times more we look at it this way, how many times you want it to retrain. Okay, so it will actually, the performance, how it's going to measure this performance of the model is like, it's going to actually take a average. Okay, so it's going to repeat based on the times that you set. So let's say the K, yeah, is you can set it at the fold over here, how many fold. So 10 fold is going to repeat 10 times. Okay, it's going to repeat 10 times internally. And there's also other factors. Okay, I'll point out a few important factors. Okay, so the input, will be definitely your matrix. Okay, because your matrix will have that's where you have the words and the weight. Okay, then that is one part. You have rows, right, with all the words and the weighting of the words. Okay, another one, you need to set your Y. Okay, so for this row, for this particular document, what is your target? Okay, let's say this row number 1 or document number 1, the target is 1 or 0. Okay, so yeah, we only have 1 or 0 in this case. So you also need to fit in your Y. Okay. When you fit in your Y, you have to specify this is the Y column in your train.headline. Okay, yeah. So it will align with the matrix. All the words will correspond to this that label. And also you can set your alpha. Alpha is the type of algorithm that you are going to use because in these functions, there are different internally, you can set how the algorithm is going to behave. If you, there are a few settings, like, for example, alpha 1, 0, or between 1, 0 and 1. So just now we talk about, like, for example, lasso regression. So for lasso, if you want to use the lasso regressions algorithms, the setting, you have to set 1. So there's another setting, reach is 0, and between 0 to 1 is like a balance between lasso and reach. They call it elastic net. Okay, so it's a mix of both characteristics. Okay, if you want to read more about lasso and regression, you can go to the GLNet package functions, the documentations. Okay. Then the fold, and then another one is the measure. Measure. Measure is in the end how you want the model to behave. If it's a binary model, then you can choose the class. You want to measure it whether it's 1 or 0, so it's a classification problem. So this is a classification problem. So so again, a bit more explanations about your alpha. So it will alpha equals 1, and then family. There's one more. Let me see. Family. Wait a minute. Oh yeah, here, this one. Family is the one that set how the model should behave. Sorry. So binomial. Binomial means is for binary class, like 1 or 0. This one, class 1, is to measure the performance of the model. Let me repeat again. The family parameter, you can set, for example, if it's a binary classifications, then you will need to set as the used binomial. So for example, if it's a multi-class, more than two classes, you have to choose a multinomial, for example. And finally, this class, it will actually set how you want to measure the models that you have trained. When the cross validation is being run, later when you are going to run the model, run the training. So when the cross validation is being run, it will actually produce one performance measure. It will measure the performance of the model. So there are a few few type of measure that you can choose. Let's say if you choose class. If you choose class, it will actually calculate the misclassification rate. Misclassification rate. So it will, when you train the model, it will actually measure back what is the misclassification rate. Is it high or is it low? So it will record. Internally, and it will show you in a graph later. So we will read the rate together. But for others, let's say it's a prediction problem. If it's a prediction problem, then you will need to use other type of measure. For example, you can go for maybe MSE, okay? Yeah, to measure the outcome when it's running the training. Okay, so this is not the final evaluation yet. This is the some observation that has been done during the model training. Okay, so if you take a look at the model, yeah. So basically just one line to train, and then you can review the model and view the the misclassification errors, yeah, in the graph. Yeah, so this looks like this. This graph actually give you some information about how about the model itself during the training. Okay, so I will come to this again. Okay, just a few lines. So the setting, same. I'm going to set exactly as the same in the slide, where you have the Y, and then you have to set the target lah. I will be using the lasso, and okay, this is the two classes binomial, and I'm going to use the misclassification error measure. Okay, let's run this one. Line 141. Okay, let's run. Yeah. Okay, you can plot. And you can also print. Okay, print the CV, print some information about this the model. So this is the model name. I name it CV. Okay. Let's see how to interpret this. Okay, if you look at this plot, there are this y-axis showing you the misclassification error. Okay, of course, the lower one the better lah. Okay, the lowest one the better. Then this is getting higher. Okay, so the dot here, it shows the measurement. Okay, it shows the reported misclassification errors during the training steps. And there's two line over here. Okay, two line. There's one line called the mean. Okay, mean line, and this one, another line is a 1SE. Okay, the mean line is the one on the left, and the 1SE is the one on the right. Okay, so here you also got this line, mean and 1SE. Okay, so go to the slide. So the graphic basically it shows a relationship between the misclassification error, and there's a setting, lambda setting, called the lambda penalties. So this lambda penalty is actually a numbers that is actually being fed into the formula, okay, of the regression formula. Okay. And then basically now the y-axis is showing you the misclassification rate lah. Okay, and then the y here, yeah, the axis, the x-axis here is the lambda, okay, lambda value. Okay, if you look at the lambda value, sorry, the lambda value. Okay, so this is the reported lambda value, 0 point something something. Okay, yeah. What the outcome is showing here is like, okay, up there, what is the up there? You have another line up there. This line, it shows you the number of feature used in the model. Okay, so slowly it's like the number of features used, like starting from 2, 4, 8, and so forth. Yeah. So if you want to know, like, okay, the non-zero features, if you see here, there's a line here. This is like correspond to this number, 585. Yeah. So at the 585, the misclassification error is this. Okay. Yeah. So this is when you set this lambda value, it's going to use, this is how it's going to the model is going to behave. It's going to use this number of features, okay, to do the classification. Yeah, to do the classifications. And if you move more to the left, if you set the lambda value even, I think here, smaller, okay, you are going to the model is going to take in actually more features. Yeah, the one up here, 1493. Okay, and then of course, the misclassification error. Yeah, here you can see this is the measure that you set. Is slightly lower. Okay, slightly lower. Just now was 0.3 something. Now it's like 0.28. Okay, it's very near lah. Okay, yeah. But the difference is this model is this setting is more complex. Okay, yeah. This is this setting is of course it's used less features. Yeah, it's simpler, and this is more complex. Okay, so the based on the input that we give to the DF, your document term matrix, the matrix that you have now, if you adjust the parameters in such a manner, so it will take in this number of like features, and this is how it's predicted to behave. Okay, so it's up to us on how we want to use the model later in the testing. You can go for this lambda value, or you can go for this. Okay, so these two is basically should be the best one because it's recording the lower misclassification error. Okay. If you go for here, the model is not going to behave well. Okay, yeah. So we are looking for either this. You can use this line. I mean the number suggested by this line or this line. Okay, so this is the the informations that about this model. So what's next is okay, so this is the so if you use the second penalty value, okay, second penalty value, this value, fewer input lah. Okay, it says you will have fewer inputs, so the complexity of the model is less lah. Okay. So let's proceed to do the validation. Okay, can we do let's do the validation now. We have already trained and checked the parameters on that the model, and let's try on the training set itself. Okay, so this will be the validations that we want to do. We are going to use back the training to test. Okay, to test. Okay, yeah. So the classifier actually have seen all the training text. It should behave very well. This is our assumption. It should behave very well. Okay. If it doesn't behave well, that means there's something wrong somewhere. Okay, there could be some missing steps. Okay, yeah. Okay, so we are going to validate. So what we are going to do is we are going to predict. Okay, use the model to predict. Okay, use the model to predict. And our input will still be the trained on matrix. Okay, because we are not using the testing yet. we will use train.matrix, the same input to predict. Okay, so we will use the model that we have actually trained, and then set some parameters. Okay, so the parameter type here, it asks us to indicate what kind of response that you want. Okay, so if you type class, that means it's going to respond either 1 or 0. Okay, the class type lah. Yeah, so it's like if it's 1 0 or xy or something like that. Yeah. And okay, there's one part that you need to pick. That's the penalty parameter. So this is how you want your model to behave. Yeah, this part. Over here, I choose the value. Okay, I'm going to choose this value lambda.1 SE. Okay, so if I choose lambda.1 SE, it's going to use this value. Okay, this value. You can either choose lambda.1 SE or lambda.min. If you pick lambda.min, it will input this value. Okay, so that's okay, I think one more slide. Yeah, so this is about the value, the input. Okay. Yeah, then it will predict for you. So the output will be a list of prediction, whether this document is 1 or 0, and you can view each of it. Okay, so let's proceed to predict. Okay, so this is the validations. Okay, yeah. Although we also say that it's predict over here, but it's actually this classification problem. Okay. Up to here. Just one line. Okay. Use back the same model, CV. Now, okay, we use the train.matrix. And then you can change this. If you want to use the left one, a more complex model, you can change to MIN, the mean one. Okay. Okay, so the mean value lah, so it will input this value. Okay, so this is okay, you can run. You can just look at the predict. Yeah. So this is the outcome, either 1 or 0. Yeah. So this is the predicted one. Okay. So the final step, we still, because now we just predicted, we're not sure whether it's correct or not, right? So what we need to do is to measure the performance. So this is where the performance metrics come in. Okay. Usually we will use accuracy and then the F1 precision recall from classification problems. You can also check out the ROC curve. Okay, ROC curve. But I think ROC curve is more effective if you are using the predictions. You are doing the predictions for continuous value. Okay. For your ROC curve, right, you need to use there's one package that we need to load later. Okay, the PROC. And the input, basically two things. One is the predicted value. Okay, here. Another one is the correct label. So because this is a training one, so we are going to compare with the train, the correct label, the Y. Okay, so this is our golden standard, the one that actually we use for training. Okay. So let's take a look at the output. We will record it as the train.auc. Okay. Yeah, basically you will get the value of the area under curve and also the ROC graph. Okay, so normally the area under the graph, they will, you're actually looking at this part. So it should be more than 50%. Okay, it should be more than the half. Okay, so that's one. There's another one, which is the confusion matrix. Okay, so confusion matrix, it will actually shows you like in a table. So let's say if the headline is like a clickbait, for example, like this, the one, the actual class versus the predicted lah. So let's say this column 117 is the one actual clickbait predicted as legitimate. Okay, yeah, predicted as genuine. So this is the one that we don't want. This the one that we don't want. Actually is legitimate but predicted as clickbait. Okay, yeah, we try to avoid. Normally we will try to minimize this and this. But these two are the correct one. Means like legitimate predicted as legitimate, clickbait predicted as clickbait. Yeah. So this is the confusion matrix. We can use this to calculate the accuracy. Okay. Yeah. So you just perform a summations on this plus this over total. Okay. So let's quickly evaluate our results and take a look at the what is our accuracy. Okay. So let's go back to the measurement performance matrix. Okay, we'll copy this together. Right. So don't forget to load the package. Okay, let's go all the way up and load this PROC package. Just load it. Do we need to plot? Not sure. PROC may not sure whether it did ggplot too. Okay, never mind, we don't load first. Okay. So yeah, here line 159, we are going to input the predicted outcome and the true headlines. Okay, the golden standards. Okay, you can run this. Okay, after that, you can display and plot. Okay, so there are two parts here. One is to display the informations and the other one is the plot. Okay, the other one is the plot. So here the area under the curve is 0.920. So basically the calculations, you're going to get the same as accuracy if you look at the confusion matrix. Okay, confusion matrix also you need to enter, okay, the predicted one versus the headlines. Okay, yeah, so this one can run. And if you display the confusion matrix, you will get the a table showing you the, okay, so this is the, let's say, okay, this is the one is the clickbait, okay, right? Yeah, one is a clickbait, 0 is the genuine one. Yeah. So over here, how to read is like, okay, you got 0 and this number is the clickbait predicted as genuine predicted as genuine, and 656 is the clickbait predicted as a clickbait. Yeah. So these are the one that you want to avoid. This 94, what exactly it is, we have to find out. Okay, what exactly it should be 0. Maybe, oh yeah, actual 0, but it's 1. Okay. So the accuracy, you can just sum. So I got 0.92. it should be very high. It should be very high for this prediction because we are using the same set as the one that we have trained. Okay. Can you share your accuracy rate? If you are using a larger split, eventually your testing will be smaller also. Suppose you are training on larger data set, you should you should be getting maybe should be better accuracy, I suppose. Okay. Okay. Aniza, so Aniza and Aini, what is your training ratio? Okay, 0.6. 0.5. So it's more or less the same, but it depends on what we have sampled also. Sometimes like by luck, I really sample something that also you know like when I train. Okay, let me see. I tend to cover more vocabs. Yeah. Milna, I think she got a higher, if not mistaken, she got a, she used a more training text. Yeah. I think, if not mistaken, she used larger set, right? Milna is 0.6. So that's why it's when you report the validation results, even it so varies, right? Yeah, I report 0.92. Then Muna also, let's say we are using the same one lah, like yeah, Muna and Aniza using the same setting, but the sampling different lah. Yeah, so in the end, like research paper, like Muna claimed, okay, I got 0.96. Then Aniza got 0.89. And then yeah, later we test Muna's model in the test, maybe we see the testing whether it still works this well or not. So it's very hard. Sometimes it's very hard to justify still. Why is it like we are doing similar steps? Then you have to actually trace back to the word level. Yeah, what happened? Because he's Mona, you're using 0.6, right? Yeah. What are the words that you have selected? Okay, so let's proceed to test. Okay, yeah, let's proceed to test. We have completed the whole cycle already. Now, we want to apply on the testing set. Okay, we want to apply on the testing set. Okay, so it's an activity for you, but I think we can do it together. Okay, we do it together. The script I also provide over here. Yeah, the testing, we will need to clean first lah. Okay, clean. What about Hanim? Do you manage to settle this one?
Actually, I just proceed with the one that I need to add the additional words to the to the headline.
The headline.
Yeah, I just
But
proceed.
can detect.
But I can run.
Oh, okay. Right. Okay, so let's try with testing data. Okay, we try with testing data. Okay. The step is actually similar. We clean the test.headline as well. So I think Hanim, you also take note of this lah. When you clean your test.headline, you open up and see whether you have I'm sure you're going to have the similar problem for this one, line 184. Okay, so you clean the test.headline, and then okay, you can compare clean.headline and test. Okay, so you have got two sets. This is my testing data later. This one is the cleaning one, the train one. Okay, both clean. Yeah, just to compare the words a bit. Okay. So next step is very important. Okay, this 192. We will need to create the DTM before we can use the metrics for prediction. Okay. So when you create the DTM, remember to specify the original matrix, which is here, this part. Okay, yeah, this part is the additional part that you need to add. So when you create the test.dtm, you pass the clean.test, and you're going to pass in the original matrix. Okay, yeah, this one, the train.dtm. Okay, so let's run 192. Okay. There's a warning message. It's okay because it's telling you like there are many terms that actually not referenced or unreferenced terms you cannot find in the DTM of your testing DTM. Okay, so if you compare this, you see your test.dtm. Okay, let's run. Yeah, this is the summary. Your test.dtm must have the same number of terms as the train.dtm. See your test.dtm. Just now I got 4997, right? It must have the same, okay? It must have the same number of terms. Okay, click on train.dtm again. We compare two side by side. Okay, total term must be the same. But if you see the entry, this is my testing, this is my training. Yeah. So definitely my entry will be less lah. The non-sparse entry, the entry that has numbers. That means because there are many terms in the test that cannot found in the training, there will be discard. Yeah. So definitely, if you look at test.ttm, it will be less. Okay. So once you are done, okay, we will convert to the matrix object before you can do the predictions. Yeah. So you can just, okay, we do up to here before we evaluate the performance. Save. So convert to matrix object here. And then proceed with the test prediction. So same thing, prediction. Just now we did the validation, right? So now you are going to pass your test data. Okay, so your test.matrix. And we are going to see use the same setting. Okay. Okay, let's predict. So the outcome name as predict test. So predict test, it will be the same thing. Okay, predict test. Let me click here. Yeah. So you will predict 1 or 0. Okay, 1 or 0. Okay, I think this line is just for your viewing only. Okay. Yeah. If you run this line, it's just show you. Okay, let me run and show you headlines of predicts. This one. Yeah. It's just show you which row. Okay. What is the original row so that you can trace and the predicted class. Okay, the predicted one. Yeah. Easier to trace only lah. Yeah. So just okay. After that, we can close this. Yeah. After that, we can recalculate, okay? Recalculate. The confusion table, okay, let me see. Let's take everything first. Okay. So the last step, again, you can just quickly calculate the AUC. Just be careful over here. Here you will need to input the golden standard for your testing data. Yeah. So that means this is the label, the correct label. Yeah. So that means we have to know the label to calculate, even it's testing. If you don't know the label, then we cannot measure the performance. So testing, the predicted for tests, can plot the AUC. Okay. So you get here. So later we are going to, yeah, it drops, performance drop. So confusion matrix. Okay. So the confusion, let's create the confusion table. Same thing. You have to input the testing one. Okay, and then display the confusion table. Yeah. You see my result is like now it's so far away from the validation result. I calculate the accuracy is 0.6966 something, right? And I got a huge number of yeah, the misclassifications here and here. Is this a good result? So I think the result will drop lah. I so far I haven't seen one that actually better, unless our testing is exactly the same, or maybe coincidentally yeah, maybe better than the training set. Because the testing is actually the unseen, yeah. If you split like this, right, it's basically the new data. You just treat like now you are reading like a new clickbait that you are looking at the new news feed. Yeah. When the news feed coming in, this model is going to predict 1 or 0, yes, no, yes, no, yes, no, like that. Yeah. But overall, after you gone through 1,500, let's say for my case, it gone through 1,500 yes, no prediction. This is the some right, some wrong, or like, then this is my result lah. Yeah. So hmm. So Mona, yours is 0.99 just now. What, so high? Oh, just now yours already so high. Very high result. Hmm. So the thing is, now the question is like, how do we trust this process? Okay, if you, let's say, for example, like Muna's case, is it because like you're so random, because it's so random, she's so lucky she got the first, yeah, predict the right one. I mean, you sample the right, I believe TF-IDF, DTM, the process is fixed lah. Okay, when you calculate the terms, but that will be that same set from yeah, we need to get Muna's training split. you your that set you don't that is the good set lah. Maybe if you take back the same set and rerun, I mean you are going to get the same result, because unless you change the setting in your model creation. Yeah, if you want to improve or you want to check out other setting, like you change your alpha, you change your when you predict, you use a different lambda. then that will change how the model is being trained and how it's going to behave. Yeah. So it's like yeah, this is, I mean, this is just a practice, like an exercise, but exactly how we are going to do to get a good model. Yeah, because now we work on this data set, but tomorrow we are going to change domain, right? Yeah, we are going to change domain. So I guess, like, if you want to build a very robust model, because this one time process is like not convincing. Yeah, we have to test different set, try to make sure it's stable. Yeah, the sampling part, because we also not sure, like, if you change to another data set, is it going to behave like exactly the same way? Yeah, so we have to we really have to conduct many times. We have to design the experiment, make sure it's robust. If we change data set also, if we change the, maybe we change the split, so we will still get that kind of range. Okay, right, that's the end. Yeah. So anybody has any message, any any questions? So this is I think it's a very interesting part to explore. You can, yeah, you can look up these references to study more. And this is just one class of algorithms. There are other types of algorithms, other classes of algorithms that you can try. Okay. If no questions, yeah, let me just pause the recording for a while. Training set.csv. You can export the data frame. Need to check out the code. Now I cannot recall. Yeah, you can just export that data frame into CSV. I think you can just quickly look up the R code. Export DF to CSV. I think Mona will export here her set. Yeah, and share with us. Then we can rerun at our end. Okay. Yeah. Okay. So let me just close this for a while, and then okay, you can save. Remember to save. So whenever you have done with a project, I think you save it, then you can still keep your previous runs. Yeah, the outcome. Okay, then you can close. Okay, yes, can save it. So I'm going to walk you through a bit on the next part. I will give you a 10 minutes break because it has been a lot of this coding, but I will just introduce a little bit on the second part later. Okay, just overview only. So the platform I will show you this afternoon. Okay, the platform I will show you this afternoon. Yeah, so the next part you will need Java. That one, if you haven't installed, you can download it during the break time later. Okay, that we got a longer period to prepare. Okay, so let's take a 10 minutes break, and then we come back around like 12, I think just a quick one, 12:40. Okay, and I introduce you a little bit about the text search. Okay, see you in a few minutes time. Okay. Okay, can you see my screen? Okay, so yeah, so let me introduce a little bit about the the text search, okay, text search, and what we are going to actually look at this afternoon. Right. Yeah. So there's a platform that we are going to look at. The name of the platform is called Solar. Okay. So Solar itself it's actually a search platform that comes with the capability of allowing us to index document and then to search lah. Okay, so the search is by issuing a query. Okay, so the idea is actually very similar to how we interact to, for example, database platform. Okay, so let's say if you want to interact with if you have some data, we can store in table, and then if you want to fetch the data from the table, we use a query like, for example, SQL query. Okay, so the idea is similar, but just that the platform is suitable for document or text related use lah. Okay. Okay. So in general, what we can do is instead of storing like a data in maybe like a database table with a column. Okay, so for this platform, it has actually enabled us to store documents. Okay, store documents, but the form of documents, later you will see how the documents look like. It will need some formatting. Okay, so the document itself can have like text, long text, short text, and it can be it just need to have some labels. Okay, like for example, okay, let's say you can think of the document as in the CSV just now. Okay, yeah, one line, one document, or the documents can take, okay, I think can take another form, like for example, XML. Okay, but the idea is similar lah. So let's say, I think CSV easier to imagine lah. So every CSV line is can consider as one document. Okay, and then CSV also has column, but the column itself, we not only can use the numerical data in the column, but at the same time, we can also put like textual data lah. Okay, you can have textual data. Yeah, so if you have a very long review like our last week CSV, right? If you have a movie review, that whole review can be in one column. Okay, it depends on how we want to design the document. We can also like have let's say CSV, we have multiple column. There can be also column like that separate where's the title, which one is the first paragraph, which one is the second paragraph. Yeah, so the design is very flexible. Okay, the design is very flexible. Yeah. Okay. But it needs some formatting lah. Okay, it needs some formatting. Yeah, but the basic format that we can actually relate to is let's say at minimally we need to have a type of at least a format like a CSV. Okay, XML also possible, but XML has more capability lah, because XML we can have the parent and child relations, and then we can have some repeated records under one same parents. Yeah, so the structures is more complex. Okay, but later I'll show you the document how it looks like. okay, when we do the practical part. Okay. So the idea is, let's say when we use this platform, we are actually able to implement a search solutions. Okay. So there can be front end, okay, like UI. So if we have a UI, then we can have a UI that similar like this is a Google like UI lah, and we key in some query keywords over here, and that keyword can be formulated as a query for Solar to fetch the search result. So the difference between the results of search, what we so called like the search results compared to let's say you compare to results written by an SQL query. Okay, a search result, it will have a ranking. Okay, that means the results written, it will be ranked based on a certain score. Okay, so how do we get the score? So the score is one way to get the score is based on the overlapping of keywords. The keywords that you enter in a query and some keywords that is being found in the documents. Okay, because we are dealing with our interest here is to look at text. Okay, textual search. So that there will be a scoring that enable the ranking of the result that matches the query. Okay. Actually, we can still use the, if you look at the SQL table, right? Actually, SQL table, we still can store textual document. We still can store textual paragraph. Yeah, but if you run a words matching, okay, if you do exact word matching, normally what you get is a list of results. Yeah, all the result that match, but there's no rank. Okay, so this is the main difference. Today we are going to focus on text search only. Yeah, but not other type of items. But I think if you use Solar, as long as there's a text, if you have image and the image has a metadata, textual metadata, we can index the textual metadata of the image to look up the image. Yeah, so can link back like video, like for example, like YouTube video. Normally you will have video descriptions, or you can have maybe the transcriptions of the conversations between people in the video. Yeah, as long as there's a text, it can be easily indexed using Solar. Okay, yeah. Okay, so these some readings. Okay, so the platform that we are going to look at is actually based on the information retrieval domain. Yeah, so if information retrieval is a field in computer science. Yeah, it's a very old field. Yeah, it started like in 1960s, I think. Yeah, if I remember correctly. So the basic idea is you must have a large number of documents. Okay, the problem is you must have a large number of documents. If you only have like a few documents, we can easily organize it, right? Yeah, you can easily categorize it, and use a catalog system to discover the documents. But here we are talking about a large number of documents. So when you have large number of documents, then according to IR, inside the documents, there are contents. Okay, so the contents will basically, what's in the contents. Again, the contents, you will have words. Okay, you have words, you have phrases, and the contents will occur in different places. Some contents will be in the title. Some contents, let's say if it's a book, you can have in the title of the book, you can have in the table of contents of the books, anywhere. Okay. So in general, if we just look at contents in general, the indexing part, it will actually grab all the keywords. Okay, grab the keywords from the documents and create an index. Okay, that index will allow us to discover back. Okay, so the index is similar to a list of words that you can search. If a word is not found in the index list, normally it's not discoverable. Yeah, unless we have other additional steps that where we can use additional method, like if you have a query keywords that doesn't match the index, then we have to do something at the query keywords. We have to try to expand the, let's say, maybe go for the synonym. We expand the concept of the keywords and try to match again. Yeah, that's alternative way to improve the matching part. Okay, but in general, the thing that we can find is the one that is already appear in the index list. Okay, so creating the index is very important, because the index will be very long, so we cannot store every single thing in the index. That's where the stop word removal comes again. So we will have the process like stop word removal. We can do lower casing. Yeah, so text preprocessing need to take place before the index is being generated. So that's one thing. Okay, so after that, when you have the index, right, that's one list. There's also another part where we need to represent the documents. This is similar to the DTM that we have seen. So given the documents, how can we store some information about the documents? So DTM is one thing, where you can use like the bags of words idea. So bags of words, we are just grabbing all the words from a particular document and represent it as a DTM-like kind of vectors. Yeah. So that vectors will be useful later to match with the search query. Okay. So basically the step is goes like this. When someone has information needs, then they will formulate the query. Okay, write keywords. That keywords, let's say if you write 3 keywords, okay, in the search box. So that 3 keywords will be asked to match with the indexing process. It will be matched with the index, okay? Because index, it will already has a list. It's just like a dictionary. So it will match with the index using that 3 keywords. And the index will be able to map all the candidate documents. So the index part, let's say I got keyword 1, 2, 3. So index, or let's say the index has all these 3 keywords. That keyword 1, keyword 2, keyword 3. So let's say keyword 1 is linked to 10 documents. Keyword 2 linked to 5. Keyword 3 linked to another 6 documents. So that's the where the index help us to discover a set of candidate. Okay, yeah. So because we know the original set is maybe you have a few millions of documents. Okay, so the indexing part help us to the index help us to shortlist all the candidates that should be returned as the search result. But after you get the candidates, we still need to match back with the keywords. Okay, so that's where the retrieval functions take place. So it will match with the keywords to measure how similar or how relevant this a candidate document is to a particular keywords, the keyword set. Yeah, so that's where we calculate the scoring. Yeah, so with the scoring, then we can return the retrieved document. So this will be actually a rank retrieved documents. Yeah. Okay. So this is the general idea of what's happening. Yeah. Okay. So there are, okay, if you look at this, there are a few parts. I'm going to just point out the important one. So the document itself, it can be web pages, can be email, can be the whole book. Okay, can be a very big, a big text. Okay, and then how to represent it? Yeah, this is the part where I talk about the DTM. You can we will keep some of the contents, and it looks like this. Okay, so this is basically similar to the DTM, yeah, the document term matrix, where you have the words lah. Yeah, you have the words and the occurrences. So inside the cell here, you can have TF, or maybe you also can have TF, IDF term weighting. Yeah. So it depends on the what kind of term weighting scheme you want to use. So this is for the matching with the query part. Okay, so information needs, you must have idea what you want to find, then formulate into keywords. Okay, formulate into keywords. And then that keywords will match with the word vector to obtain the subset of the documents. Okay, yeah. So the I think the common way of doing the similar the matching will be the normally we use the cosine similarity matching functions, yeah, to match each of the candidate documents with the query, yeah, and then you sort. The cosine similarity matching will give you a score. So about the indexing part, that's the steps where we try to get a good index data structures. Yeah, because index itself, it can have too many words. Yeah, because basically the words come from the contents. So this is the part where you need to perform the standard steps, like tokenization, stop words removal, stemming, yeah, phrases generations, and then lastly create the inverted index file. Okay. So this is the place where stemming occurs. So last week we talked about stemming versus lemmatization. So stemming, if you compare to lemmatization, is a much faster process. Yeah. So for retrieval index generations, whenever there's new document, crawl by the let's say the web crawler, or there's an update to the document, we need to actually re-update back the index. So the process need to be fast. So stemming is still heavily used in the IR area. So example of inverted index is once you have found the list, let's say this is a good list. Okay, just assume this is our index. So the inverted index idea is to create the mapping between a terms and the documents. So once you get this inverted index, or sometimes it's known as the posting list, our lookup is very fast because we already got this. This has to be run offline, the pre-search time, pre-query time. They call it, this is like a pre-query time. Yeah, this has to be run. This is an indexing time process. So that means this has to be ready before query. Someone can issue a query. Yeah, once this list is formed, right? Whatever keywords that come in, we just need to match with the list. So let's say we have 3 keywords, the keyword just match. Okay, it's hot summer. And then we already can straight away fetch this subset of documents. Okay. And once you get the subset of documents, we can use the retrieval functions, any retrieval functions that help us to calculate the score. So you can get the document score. Okay, so this is the, okay, yeah, I think this is about it, the general idea. Okay. So what we are going to look at this afternoon is the ad hoc search task. Okay, ad hoc search task. So ad hoc search means that the search is like one-time search is like from a query. Once someone fetch a query, I'm going to get the query and fetch the search result and display the search result back to the user. And that's the end. Okay. If you want to search again, then we have to pass in the query again. Okay. Yeah. But nowadays, like if you look at like the search engine, the front end, when they display the search result, they also give you many tips what to search next. Okay. But that if you click on any of the link also is another loop lah. Okay, is another processor. Okay. I have actually I have shared this book in the e-learn. You can take a look at the book, and also you can see it from this. You can get it from this website. The book basically has is about the different parts of information retrieval. Yeah, about the very fundamental concept. Yeah, you will find maybe like indexing one chapter, query one chapter. Yeah, very detailed. Okay, so I'm going to stop here. This afternoon, I will just walk you through the, okay, yeah, this part. Okay, we'll continue with this part. How solars actually works, and the how it can, okay, basically this one. Okay, so this is the interface, how it can index and how it can allow us to query. And a reminder, just a reminder, remember to download this one. Okay, download. Let's open the link here. Yeah, so you can download the JDK. Okay, to download the JDK. And there's also another thing that you need to download, which is the Solar itself. Okay, open a new link. Okay. So for Solar zip, you will need this the .zip one. Okay, the binary release. Okay, this one, this file. Okay, so download this one. Yeah. So once you download this zip file, you just put it somewhere in your local drive. We do not need to install, but just unzip in a local folder. Yeah, one local path to be able to use this. Okay, so two things. One is to download the Java JDK, and another one is to download this one. Okay. Okay. Before we go for a break, do you have any question? So you can refer to the stack as well over here. So you can get these two software ready, okay, during the lunch break. Just let it run, just download and let it run. Few options. Which one? Okay, I go for the, okay, let's say I'm using window lah, yeah. So I go for window, and I see. Okay, do compress. Should you just download the installer lah? Yeah. Then you can download this installer. The .exe lah. So when you can yeah, just you download the exe, it will walk you through the installation. But for those who already have Java in your system, it should be usable. No need to reinstall. Okay, if you already have you have used the Java before, no need to reinstall. Okay, Muna, noted. Thanks. Or maybe you can share the Padlet with others so that they can also try out. Yeah, you can just share. Yeah, then they can also try to run whether they can get the 0.99 or not, or 0.9 some. Yeah. Okay. All right. See you later. So let's take a break. So I think now it's around 1:08. We come back at 2:10. Okay, 2:10 p.m. Yeah, once we come back, we can start setting up the platform, and then I'll show you how this works. Okay. All right, see you later. Okay. So the WebEx I'll leave it on. You can rejoin later. Okay, good afternoon. Okay, shall we continue? All right. Okay. Let me show you. Okay, so yeah, let me just show you a bit on what is going to happen at the back end later. Okay. Okay, so at later we will actually try to index a document. Okay, and then the document looks like this. Okay, so a document it can have, for example, ID. It can have sections like title. It can have a mix of like, for example, here this is textual data. It can also have some numerical data, like you can have price, numbers, dates, other value. Okay. So basically, you can have a mix of different type of contents. Okay. So this the documents will go through the indexing process. Okay. So the indexing process will generate inverted index. Okay. So the creation of index inverted index is automated process lah. But the process that is taking place at the back end, we can actually customize it, okay, on how we want to process a certain part of the contents. Okay, this can be customizable, okay, but there is a default pipeline as well. If you don't customize, then we will be using the default one. Okay, so the keywords from the contents of different parts will be converted to something called this Lucene inverted index. Okay. So when a word is created, for example, charming, it will be actually mapped to the field. Okay. Yeah. So for example, charming, okay, is mapped to the title field. Bungalow as well. Okay, so it will be recognized that there will be a few different inverted index based on the fields. Okay. And then, yeah, that's the posting list where it's mapped to a document. Okay, so the 2x here means like it appear in 2 documents. So this is the document frequency, DF. Okay. And the posting list, okay, so in the posting list, it records lah, like bungalow, actually it is posted to document ID 44 and 97. So 44, the word itself appear 5 times, 97 appear 2 times. Okay. So apart from the basic keywords and the documents, right, you can see inverted index also keeping some additional information like this, like especially the frequency. Okay, yeah. So all this information are useful for calculations. For example, like if we want to calculate maybe a term weight later, so we can actually use this information. But all this will be done automatically at the back end. Okay, so at the other end, query. So a query will go through a query processing pipeline. Okay, also customizable and will be mapped with the index. Okay, so basically this is what happened at the back end. Okay. Okay, this is a schema. Okay. We are not going to create a schema, but we will let Solar create the schema for us. Okay. Yeah. So it will basically the fields can be auto detect. Okay, it will be automatically detected when we index a file for the first time. So I'll explain it again when we come to this step. If you see what the schema is keeping, it's very similar to how we define a table in let's say in a database lah. So it will recognize like what are the fields, okay, which has been actually that appears in your document. So fields can have like maybe field name, screen name, type. So this is the one that will appear in the document as well. Okay, and then some other properties, whether that field is keeping the content of which type, can be string, it can be a date, okay, and others integer and others. So this is a schema that is has to be the schema will be created and it will be referred to when we want to index the files again. Okay, so this is one thing about schema. Okay. So what we are going to do in a short while is we will be creating something called the Solar Core. Okay, Solar Core. Okay. So you can think of a core as maybe if we have search problems or we are dealing with one collection. Let's say the collection is movie review, then we can have one Solar Core, and the other collection can be abstracts of books. Then that can be another core. So once we create a Solar Core, it will allow us when we add documents. Okay, we can add documents to the core. So when we add documents, like okay, we got documents, we add documents, we can use this document management module. We can add, you can update, you can delete document from the core. Okay, So once the document is added here, it will go through, basically it will go through this process, text analysis pipeline. Okay, so there is a default pipeline where it will go through the tokenization and a series of filters, stop word removal, lower casing, synonyms, handling, stemming, and so forth. It will go through a steps of a text analysis pipeline, and then the balanced words stored in the as the index. Okay, yeah, so this is how it works. Okay, so when the document go through this text analysis pipeline, when it enter it, it also refer to the schema. Okay, it also refer to the schema. So that it knows, like, okay, let's say there's a word bungalow. So later on, bungalow will be bungalow need to be, let's say, a string type, and then it will be stored in a field, like just now bungalow field is title. Okay, yeah, so it will be stored under the title index. And okay, so when there's a query also come in, it will go through a query processing steps. So there are some steps like spell checking, visiting, and so forth at the query for the query side. And also it will go through a text analysis pipeline. So the the query will also, if there's a stop word in the query, it also will be removed, okay, before it go to the index for matching. So this is the back end, the main component, that back end. To skip this, yeah, we can proceed to the installation. Okay, so once you install Java, you can just do a quick check lah. Yeah. Okay, and okay, you can go to command. Let me just exit this one. So you can search your command prompt cmd. Yeah, so you have to install Java first. Okay, have to install Java. So you go to the first one is like, I'm going to just check my Java whether it's already there. So I just type Java dash version. Okay. So you can try this step at your end. So you go to command prompt, just type cmd or command in the search. Then open it. Okay, then you will get this. You'll come to this command prompt. So the next step is the. Okay, so once you have installed, okay, there's a configuration that we need to do at the system. Okay, at the property. Okay, let me show you. The location is at the advanced system setting. Okay, so you can look up by advanced system setting. Yeah, you need to make sure the path is there. Okay, so you go to system. You go to system property, environment settings, environment variables. Okay, open. So firstly, you need to add this Java underscore home. Okay, you need to add this. If there's none, you have to new. Okay, you have to new. Okay, so if I add it, it looks like this. So you need to enter the variable name Java gets underscore home, and the path to where you install your JDK. So this is the path. You can browse. Okay, just browse to the path. Okay, so this is the first path to add. Okay, yeah. So you need to pick the JDK folder. So I leave this screen on for a while. So basically, you need to find your advanced system setting. So you go to your system properties, environment variables, open up, and then here you just type new. Okay, if there's none, you have to click new. Okay, this pop up. Then you enter the variable name and the value. Okay, the value you can browse. Yeah, where you install your JDK. Okay, yeah. So where do you install your JDK? Okay, so that is the first path. Okay. The second one is inside here. You have to click on the path. Okay, you click on the path and then you click edit. Okay. The second one is here, path, edit. Then you either add or edit. Okay, you add, let's say you add, you just click new and then browse to the path where you have the JDK, but the bin folder, BIN. Okay, so the folder is a bit different. This one is you have to select up to BIN. So you select this path. Okay, so after you set, we will try to, yeah, we will know that later when we start, because when we start solar, if there's an issue, then we will come back to solve this. Okay, tool setting. Okay, again, so one is at the Java home. Here, you need to click new. Okay, and then key in the variable name Java underscore home and browse to the path where you install your JDK. Okay, the second path is this one. You edit. Okay, if you can add can new one path to your JDK / bin. Okay, you can do this now. Okay, so once you are done, okay, okay. So this is the screen. Okay, once you are done, you can unzip your solar. Okay, you unzip solar. This is the download. Okay. So for my solar, I unzip just directly to my C drive. Okay, so you can unzip into your local path. So once you unzip, it will have something like this. Make sure it has similar folders. Okay, so like this. This is my version, which is a bit different. Okay, so you will unzip and then you will see something like this. Yeah, so you just unzip. Okay, so this is the path C and then solar -8.1 8.1. Okay, so this is my path. Okay. So what I want you to unzip into, local folder here. Okay. So after that, you can try to start the server. Okay. Solar itself is a server, just like web server. Okay, because so that you can actually issue any send in any query to the server to fetch the file. Okay, so what you need to do here is to start the server. Okay, so I can go to this page. So at the command prompt, I go through until here first, then you can just troubleshoot. Okay, so you need to go to the path where you install or you unzip your Solar. Okay, so mine will be at the, I will type CD, which is stand for change directory. You can, if you want to go to the root, you just type a slash, backslash, and you can, okay, but my Solar is at, so you type change directory again, space, SOLR, this is the folder, okay, 8.8.1. Your Solar is different version, so just follow your own version. You follow your own version. Okay, so this is level 1. If you directory means you are listing the folders. Okay, you're listing the folders and the files in there lah. Okay, I need to go to the bin. Okay, yeah. So cd space bin. Okay, again inside there are some files. The file that I need to run is this one, Solar SOLR. Okay, SOLR space. The command is start. Okay, Solar space start. Okay, Solar space start. Okay, enter. So if your server start successfully, you will see there's a bit of information down here. Yeah, mine's still starting. Okay, so you can see here, started Solar server on port 8983. Happy searching. Okay, so that means the server already started. So once you have started the server, you can go to this site. Okay, you copy the link. Use any web browser. Okay, I will use Edge. Yeah. So this one lah. Okay, so paste at your web browser, enter. You will see the admin. It's the admin dashboard. Okay, so you will see this. Yeah. So once you see this, that means so far I think everything is so far so good. Okay. Yeah. Maybe one more obstacle is the indexing part. Yeah. So once you can see this, that means your server already started. Okay, if you get to this page, can you type number 1 at the chat box? If you can, if you can already can access the Solar dashboard, admin dashboard. Yeah. Can you type 1 in the chat box? So if you are not sure what to do, you can ask me in between. Okay, let me open my command prompt again. Yeah, so you need to okay, how do you open the Solar admin? Okay, Solar admin, there's a path here in the slide. Yeah, you need to, actually it's a web page. So you just go to your local host at this spot. So you copy this link and go to any web browser. Okay, use any web browser and open it at this this part. Okay, if you don't have Java Home, you have to create new. Okay, make sure it's capital, Nisa. Okay, so you have you click new. So I go back to that again. Environment variable system. Yeah, you can click new. Okay, new. Then you type Java Home. Yeah, this one. And then browse for the JDK directory. Okay. Zaid, your not in zip file. Actually, we need this. Yeah, can you download this? Okay, sorry, this one. Yeah, so you download this one. Yeah, once you have downloaded, you just unzip. Okay, unzip. Then you get this. Yeah, so you can get this. Okay, what about the rest? If you have any question, yeah, we will spend some time setting up and make sure just start the server. Okay, start the server. Yeah. Not sure. Can you can check the file name? Afiq, you can check the file name. This one. My folder is a different version, the much older version. So I think latest one is the this 8.11, 0.3. Okay, directory for Java Home. So Anisa, you got to wait. You need to browse to where you install your JDK. Okay, so here. So okay, I'm going to edit. So this one, this is the place where I install my JDK. So you can browse. You click browse, and you have to find. I think mostly it's in the program files. I think should be around here. Okay, programs file, Java. There. Yours may be different. Yeah, but just point to your JDK folder. Okay. Then another one, the path. Okay, path you got to edit. This one you got to add new also, but this one you got to pick the bin folder. Okay, JDK something, and then the bin folder. Okay, two paths to add. Okay, you try to add first. Okay, after you add, then you can open up your command prompt. Yeah, and try to start Solar. Yeah, the command is here also. Okay. So basically, if you want to change directory, you can use cd dot dot, okay, two period or two dots to go up one level of your folder, or you can use a slash. If you use cd, if you type cd slash, it will go to the root. Okay, it will go to the root of C. Okay. Then because mine is at C, so it's straightforward. Okay. Yeah. So you need to type change directory to the path. So you follow your own folder here or path. So you need to get to the path. Once you get to the path, we still need to go to the bin folder. Okay, you need to go to the bin folder. And wait, okay. Then Solar start. Oh, so when you type Solar start, it cannot find java.exe. What about this one? Have you added this? Okay, this one, edit. What about this path? This one. Aini, have you added this one? Yeah, also. You point to bin. This one. JDK and then bin, the bin folder. Okay, if you have done that, try, okay, another thing you can try is can you close your command prompt and open again? Just in case you have, yeah, just now you have added something after you open it. Can you exit? Yeah, you can type exit. Okay, close and open again. You try and see. Any other question? So if you, okay, how many already see happy searching? Anybody managed to get the happy searching? If you can type number 1 in chat box. Just want to see whether this this new Solar version, whether it works or not. Yeah, because you are the first batch trying it. Yeah. Not sure whether the release date, one of the latest release. Okay, Muna, you get happy searching. Can you open this? Okay, not this one. Can you get the admin dashboard? Yes. Okay. Yeah. So you can just take a look at the other few slides first. Anybody else get the happy searching? Other than Mona? So, Aniza, do you manage to set your Java home? Okay. Afiq, you can try to unzip. So Zaid, once you're done, you can try to unzip also and then test, yeah, test it out. Yeah, because normally after we run, then you will know, yeah, is there's an issue with the previous setting or not. Okay, so when you try to start Solar, just make sure the path is correct, pointing to exactly where you place the Solar folder. Okay, so basically bin folder, it's this one. It's here. Okay. You can see the files in here. Okay, so let's wait a little bit for you guys to try out. And any questions from others? Where did you place the? Okay, wait. I think Fahmi, you may have unzipped in the different folder. Okay, just Fahmi first. Okay, because basically when you type change directory because you are actually moving to that directory lah. So where my solar is over here directly at C, so I can change directory to this folder. It's like you have to be directly under C. If you put under, let's say, users, okay, like Aniza, you have to change directory to users first, and then again, or you can type the full path. So where do you put your solar farming? Okay, so like Aniza case, you should be like this, cd users slash like this. Like this. Okay. Is it inside the document or is in one more folder in document? So you have to yeah, be careful with that. If you want to go one layer by one layer, you are going to type change directory to users first. That means it will move from C to, it will change from C drive to users folder. Okay, then inside for users folder, you type again, change directory to 60176. Okay, yeah, it's like one level at a time. But for me, I need to know where you put your solar. Where did you place this? Yeah, okay, where did you place this? Because my folder, I unzip it directly in C. Okay, so I can change directory just from C directly to this one. And then again to bin. Okay. Yeah, so where do you store your solar? You put into one more folder. Oh, okay. So you can you just like let's say over here, you just wow, maybe let me try mine. Program files got space. So it's okay. Yeah. Okay. So yours will be program file space files. Okay, space solar. 8 3 thing like this. Yeah. But if you want to run solar start, then you have to go to the bin. Okay, one more level. Yeah, but you can get to solar first and then go inside the bin folder. Okay. Anybody else get a happy searching? Other than Muna, who else get the happy searching? Set. Anisa, maybe do you want to share screen? We try to troubleshoot. able to find the registry key. Okay. This the error also talk. I mean, it specifically also mentioned Java Home. I think should be okay. Just a moment. I make it full screen. Oh, okay. I think okay. Can you click Java Home? Yeah. You edit. Okay. Can you remove the bin folder?
The
And
/ is remain.
slash. I think slash. That you can remove the slash. Yeah. So this is your JDK tutu dash tutu.
Yes, yes.
Okay. Can we check the path also? Sorry, can you open again? Yeah, just now environment. Yeah. Path down there. No, no, not this one. Under OS. Yes. Can you click edit? All right. Okay. You can click new. Can you click new? Yes. Can you browse? Click browse. Yeah. Then can go back go to find the JDK/bin.
Oh, the JDK.
Yes. Yeah. I think the program just now under where program files. Just now where did you I think you go to this PC. This PC. You scroll down. No. Where is
I
your
store it
Java?
under C.
Under C,
Yeah.
okay, okay. So how to find the C here? Yeah, okay. Yeah. Okay. Yeah. Bin, bin. Yes, this folder. Okay. And click OK. And click OK. OK again. Yeah. Okay, here click OK again. The command prompt, can you close, exit, and open again?
Oh,
It should
okay.
be working. Yeah, you try and see.
Oh, all right. Okay.
Okay.
Thank you.
Bye. Okay, welcome. Okay. Yeah, so for Aniza later, okay, you try to close and open again, okay? The command prompt. What about others? Just take a quick check. Yeah, do a quick check again. Fahmi, are you able to start? Okay, it's still trying to get to the bin, right? Okay, sorry. Yeah, it's okay. I think I just try to troubleshoot a bit more because normally this is the part where you start. Otherwise, the rest I think should be quite. Once you can go to the admin, we are going to use the form, yeah, to send the query. Okay, Afiq, is your issue same as Aniza just now? Can you share screen? Okay, so we take a look at the advanced, the system setting. Never mind this one. You go to the system. Maybe you close this first. Can you close this? You close this first, and then you go to the. You are here, right? Okay, your Java home is correct. You browse to the path just now, right? This one. Okay, can you click on the path, the one under OS? Yeah, edit. All right, it looks okay. The last line is there. Can you click OK? Oh, okay, click OK again. Click OK again. Don't click close. Yeah, okay. And then can you open your command prompt again? Yeah, we start. Okay, where's your solar? Oh yeah, same. Okay. So okay, CD you can put a back. Okay, you put a you can no Afiq not yet. So we have to go to root first. Easier slash. You could yeah, a slash, a backslash. Sorry, forward. Okay, right. Okay, enter. Okay, this will bring you to the root. Okay, so can you type CD change directory space? Okay, SOLR, that solar name, dash, a dash 8.11.3. Okay, you straight away go to bin folder. You put a slash bin, slash bin. Yeah, enter. Okay, we are here. Okay, yeah. Can you try solar start? Space start. Yeah. I think this one got to allow. Yeah. Okay. I don't close. Once. Yeah. Don't close the command prompt. You just go to the browser. Yeah. I think you are okay. Doing fine already. I'll take over the screen. So basically, it's like that. I think the rest also could be similar issue. Yeah. If you want to troubleshoot, you can let me know. Yeah. So after a minute or two, we are going to move to the next step. Okay. Okay, last call. Okay, later if you are stuck still, you can let me know. Okay. Right, where are we? System cannot find the path. I think Zaid, your where did you unzip your solar? It must be, I think it could be in another folder because this path is you you change to this path.
Yes. This is the path.
This is the path. You want to share screen? I troubleshoot for you.
Yeah.
Because this path, right, it cannot, it's supposed to be here. Okay. Can we take a look at your...
Okay, this is the folder path.
Oh yeah, it's there. So what happened? So weird. Can you double click on the folder? Make sure you got the right solar. Oh, another folder. You got a
Yeah.
double folder.
So
Okay. So now you got two layers. Inside solar, there's another solar. Can you move the, okay,
this
you
one?
go to folder, yeah. You just copy everything out to the outer folder, yeah. You got two layer. You paste. No, don't paste here, paste in the solar folder. Yeah, paste here, yeah. Okay, so you can remove the additional solar folder. There's one empty one. Yeah, you remove this. Just delete. Yeah, okay, now you're good. Okay, I think it will work now. Yeah, you can go back to your command prompt.
Okay.
Just, I think you can put the up button. You will go to the previous command. You can use the up button. Yep. Yeah, enter. Yeah. Just now you got additional path. Can you try solar start? Yeah, we take a look together.
Solar.
SOLR, SOLR, no A, SOLR, yeah, space, start, START, yeah. Okay, can enter. Okay, it works.
Okay, thanks. Happy searching.
Yeah. So, whoever you once you get a happy searching, you just point that path, the local host at this that at that specific port into this one lah. You open any browser should work. So you just point your path to the this one, okay? To the open it at the browser. Okay. So let's continue. Okay. Yep. So if you want to check solar is running, you go this. That means you just open up the path here. If you see the port used is the number is 8983. Okay. If for those who are familiar with the web server, normally web server runs on 8080 lah. Okay. Yeah. So in case this port because this is default it will pick this port. In case it has been used by another process, you can actually manually specify the port that you want to use. Yeah, by adding one more parameter here. Okay, so check your admin dashboard. Okay, once it's up, okay, this is how. Yeah, at the end of the day, remember to stop your server. Okay, so this is the command. Okay, so normally we forget later. The command to stop your server. So solar space stop. You do it later lah, huh? Then you can either use if you use parameter the specify the port. You have to tell which port number 8983. Otherwise, you press if you enter dash all, it will stop all the processes. Okay, yeah. If you forget the port number, you can just put dash all. I think normally we will have one process running only. Okay, so you can use this to stop the server later. Okay, I'm going to, okay, let's start with the basic search. So recall just now we talked about the core, okay? The core, we have to create the core first, just like a project. Okay, after we create the core, we can try add documents. I can update, delete, search, and index. Okay, so now it's empty. Okay, let's start by creating the first core. Okay, we go back to the command. Okay, we go back to command here. So still at the same folder, show you the command to create. To scroll. Okay, you can refer to the slide lah. Huh? So you the command is solar create. Okay, you can check the slide also. It's like the command solar create. Okay, then dash C. Okay, and type the core name. Okay, so you can type the core name as tag product. Okay, I'm going to add one extension. You can type tag product lah. Core name. Okay, your core name is here. Okay, so you type enter. So it will tell you created new core. Okay, the core name. So when you create the core, just using this, like just enter the name, it will create the core with the default schema set. Okay, this one. It will actually duplicate one default configuration folder for you. Okay. That default folder, what it does is, later when we run the indexing for the first time, when we index, we need to have documents, okay? So when it run indexing for the first time, it will detect all the fields in your document automatically, okay? So it will detect, let's say the document have 3-4 types of document, maybe 50 fields inside, it will detect and it will construct the schema for you. So this is the default set lah. The first thing the default set will do. Okay, there are pro and cons. Okay, but the pro is it will create the schema for you. Okay, the second thing, the con is like, if the first round there's some issue with your data, the documents or the content type, the schema that is created, because it's going to follow the first time you run the indexing. Okay, so it will be based on that only. Okay, but in the future, when you run indexing second time, third time, it's going to refer back to the schema. Okay, so there may be a mismatch. But what you can do is, normally we can create the schema by using this automated method for the first round. Yeah. So in order to ensure that a correct schema is created, right? The first set of documents that you want to index must be I will say it must be you have to make sure it covers the scopes, like what are the fields you want to include, and also the sample, the data in the field must be of the correct type. Okay, so that is I think it will, at least it will create a correct schema during the first round. Okay, so now we got the core. Okay, let's check out where it is. You go to your admin dashboard, the panel, this one, go to core selector. You will find the core in your drop down. Okay, yeah, you click here. It's in the drop down list. You select the core, and okay, this one is can rename lah. Okay, or delete. Okay, you drop down, then you will find a series of tabs at the left side. Okay, so let's go to okay, I'm using Edge over here. So I've created my tag product. Okay, see. Where's my core? C15 TCH. Okay, let me refresh. Yeah, I think you got to refresh. Okay, so this is the core created. Okay, You can see there are some informations here, like number of dogs, there's none yet, so it's 0. Okay, and where do some of the instance data located in your drive, and a few tabs over here. Yeah, we will try some of the tabs. Okay. So this is core. There's one thing is you can also check out the folder. Okay, so once you create the core, you will have one folder created under server. Okay, server Solar. This is your core folder. Okay, you can explore this a little bit, see what's inside. Okay. So next step is we want to add some documents. Okay, we want to add documents because now it's still empty. Okay, our first set of documents is already there. Okay, we are going to use the examples. The example is located over here at the Solar folder, example docs. Okay, there are many documents inside. We will index the XML file. Okay, we will index the XML file. Okay. Okay, I cannot see the XML file over here because it's been detected as HTML. Okay, so file like this is a XML. Let me open up. Yeah, this is the XML file. Let's index first, then I'll explain about the files. So, okay, how to index? Okay, go to your command. Let's go to the example docs path. Okay, so the path is actually one level up. So you have to go up one level. You type cd ... You go back to Solar folder. Then you can change directory to example docs. Okay. Yeah. So this one. Yeah. So this is where your the examples are. There's also one tools, okay, a Java tools in the folder that we are going to use to do the posting or indexing. Okay, show you where's the tool. Okay, when you install this, the tool is, yeah, this is the posting tool. Okay, they already placed in the same folder, but it's a movable. You can move to other places. Okay, so it's here. So what we are going to do is we are going to use the Java command, Java -jar. Okay, DC, capital D and small c over here. And your core name. Okay, remember your core name correctly. Okay, this is your core name. After that, type call the tool. The tool name is post.jar. Okay, and finally, the last part is what are the files to be indexed. So this round, I'm going to index, we start with all the XML files in that folder. So put star.xml, okay, star.xml. Star means everything lah, the clean star, okay, everything, all the file names, anything and then that end with the .xml file extension. Okay, so you can click enter, just check whether the spelling is correct. Click enter. Okay, so you will see these are the XML files, HD, iPod, MEM, money, so forth. Okay, I think, okay, I got 15. You will have 14 because I have actually copied the tweets.xml inside also. The tweets actually is for another testing. Yeah, but already added inside. Okay, you should have 14. Okay, 14 files index. Okay. So once you and you can also see the indexing time. Okay, the indexing time. So what is your indexing time here? if you want to check the speed of your the processors, you can test out the performance of a computer. You can actually use the indexing time to test as well. Yeah. Okay, so it's in general, Solar should be able to perform the indexing very fast. That's why you can see one of the tagline there is like it's blazing fast. Yeah. Okay, so but then this is only a very small size. Okay, very small size. Right. Okay, so let's check out where's the documents that we have indexed. Okay, so this is the status. Okay, let's go back to the panel, the admin. Okay, the admin. Okay, you can refresh. Once you refresh, you will see the number of docs. You should get 32. Okay, should get 32. And then you can click on query. Okay. So so what you can do is, okay, this is a form. And okay, in the form there's this part where you see there's a star, colon, star. Okay. So the first part indicates the field to search. Remember when we look at the indexing backend, the content document come in, content go through the tag analysis process, generate into token. Token is going to convert into the Lucene index file. Lucene index file is going to index against a specific field. Okay. For now, okay, I'll show you how to let it index across every field. Okay, but now it's going to index against a specific field. But here, stars means you have to type what is the field. Second is your keywords. But then just try to execute query first. Okay, because stars means everything. So here it means everything. Here also everything is going to display all the documents that you have indexed. Okay, you can see this is a number found 34, yours is 32, and this is one record, this is another record, this is another one. Okay. So for document retrieval or document search in Solar, this is one document. Okay. Yeah. Okay, this document, it looks like it's a mix it's a mix of some structured text and unstructured. Okay, it got keywords. You can also have different types of documents over here. You can have like one document ID, maybe a book title, a book abstract, the table of contents. You can have different format. Yeah, can you recognize this output? What format is this? So when we are using the Solar dashboard, admin dashboard, it's when we interact with the server, right? This kind of dashboard is still for development use. Okay, that means it's a development for developers. The dashboard is not for end user. If you want to deliver this for end user, we still need to develop one front end for it. So you can try the query. Okay, so let me see. Yeah. So you can try out one query. Okay. Okay, the question maybe later. Yeah, you can try this query. So for now, when you want to query, you have to specify the field names. Okay, so for example, the category drive. Okay. So let's go back here. Let's say, okay, this is about products, technical products. So the technical products, they have category, they are electronics, hard drive, and so forth. Okay, so you can just we try one query. Okay, category belong keyword is hard drive. Okay, and then let's execute. Okay, so two search result. Okay, that matches category and hard drive. Okay, yeah. There's also one query here with a Chinese character. Okay, let me show you this. So basically, Solar actually support multilingual content indexing. Okay, where's the Chinese word? Let me copy. Yeah, it can actually match the contents in another language as well. Yeah, apart from Mandarin, if you check out the stop list, stop words for Solar, there are many language. Like if you have a content in like Japanese, Korean, I think Arabics, many lah. Yeah, it's in the. You can see it here. Okay. You can also try to index a document in other language. Okay, let me find where's the stop list. Server, Solar. Okay, here. So this is the core, okay, that we created. Now if you look at the language, okay, configurations, language. Yeah, just look at the stop words provided. You can actually use the stop words in the pipeline, the text processing pipeline. Okay. I remember there's one, no BM. There's one ID. Okay, close, but not exactly. It's our same as BM vocab. Yeah. But if you want to add your own stop list, you can just put one dictionary over here. Stop words dot my. Yeah. So this is the one of the stop lists from the effort of this stemming effect is generated from these projects. IR in Bahasa Indonesia. Yeah. So you can see this. This is one of the stop lists that comes with Solar. Okay, we minimize this. So just to show you the text processing, yeah, we can have this capability. Okay. Okay, next step. Yeah. Oh yeah, there's a questions. Remember your total of file index was 14, but why there is 32? Okay, see. If you display all, right? Just now if you search all, star, colon star, yeah, execute. Why is there like 32 for your case? So just now what we did is we index star.xml. Okay, we index the star.xml file. Yeah. Can anybody want to guess? Why is it like we are getting 30? If you start right, start from 0, and I want to display all, I can type 32. Okay, let's say I type 32. Execute. It's going to display all the documents. Some short, some long. Yeah, so it's very flexible. Even if you have different type of input, it's going to be able to create the schema and index for you. So you see this one, all the field types. Okay, so let me show you where is the raw file. Okay, just now I think I opened up one raw file. This one, yeah. Okay, so in the XML file, there are multiple XML files for different, I think, products, manufacturers, and so forth. But one XML file can have a few documents. That means one XML inside one XML file, you can define more than one document. So over here, this is the start and end. Okay, you see this one? Yeah. Start of one document, end of one document, and the field names. Okay. So if you format the documents using XML file, we will need this format. So you have to include field names content is in here. Okay. In order to add the document, we also need one extra command. You see here is add. So this is when you index is telling the document management module that we are going to add this in. Okay. So so this is the XML format lah. There's another one is a CSV. Okay, yeah. So I think CSV could be more is more common lah. But XML file also quite popularly used. So, but this is how it looks like. It can have like combinations of text and some other type of data type. Okay. So this is the document. So what you can you see how we can use the browser to interact with the query. If you go to your panel over here, yeah, you key in something in the form, right? Okay, let's use this name iPod. Okay, if I enter here, okay, name. Okay, I want to look up all the products lah. Name iPod. Okay, and I click execute. So it's going to match lah name with the iPod. Okay, and if you see here, it's actually this input is just like a search engine search bar. The search form is going to fetch this information, name and iPod, pass it and extract. So it will detect, okay, our query is actually you have name, okay, and then followed by this column and this iPod. Okay, row 32 is because just now I go and set row 32, but if I don't set anything, default one page of search result is 10. Okay, so that's the default. Let me send again. Send again. Yeah, the default one is 10. Okay, so this line is a HTTP request. So you can copy this, which is what we are saying here. So if you have any front end browser, we can fetch we can make the form like this, and it can send. Basically, it just send to the server, and we will get back as the result. Okay, so this is can anyone recognize this format? What format is this? When you get back this format, you cannot display like this. We have to reformat it and display as a search result. No, the raw one. Yeah, this page is HTML. You're right. But what response is this? Yeah, this one. What response is? Okay, I show you another one. This one is XML. The default one is JSON format. Okay, the default one is JSON format. This is not this one. Come back here. Another one. Yeah, this is the XML format. But if you return the XML format, then we will need to have an XML parser. Okay. There's also a few other format. Okay, a few other format, like where is it? Yeah, at the WT here. Okay, yeah. So basically, WT, the parameter allows you to select the response format, how the server is going to respond back that search result. If I pick, you can pick CSV, you can pick PHP. If I pick PHP, this array actually can be directly read by the PHP script and look, and you just need to look whichever part of the array and display at the front end. Okay, so if you have CSV, comma separated lah, yeah. Okay, so this is but this is the default one. Okay, you see, like the JSON, yeah, it's the same. It's the default one. Okay, you can also remove documents from the core. Okay, but we don't remove first. Okay, our next exercise demo, I'll show you how to remove. Okay. So if you want to remove documents, we can use one of the tab documents, and pass in the this is one type of the command lah. You can pass in the XML command. Okay, and just now when we want to add a document, we say that add, right? So if you want to remove, we pass in the command delete. Okay, delete, but delete what? Let's say if you want to delete all, what we need to do is tell that I'm going to submit this query. Okay, and what is this query? Star colon star. Yeah, if the query says star colon star means everything is going to delete everything. Okay, but if you want to match a certain file, maybe you can query ID equals number 1. So the file with ID equals number 1 going to be deleted. Yeah, so you can use this this way to remove a document. Okay, and then okay, so we don't do this first. Yeah, verify after delete. Okay, add back, and let's see. So paginations, default is 10. Okay, default is 10. Yeah, but if you look at this form, right, it's actually it already has this pagination setting. You can start with, okay, next you can start with number, let's say I think it starts with 10, because just now it starts with 0 in the array, so you start with 10, execute. Oh, we don't have results because it's too little. Let's say start. Yeah, this will be the second page. Okay, second page. So it's how the search engine front page, they control like maybe first 10, second, the second page, third page, and so forth. But I think nowadays Google don't use this anymore. No more paginations, right? Are you aware of that? Like, it's like we can keep on scrolling down. Once you scroll down, it reveals more results. Yeah, so it's is it friendlier, or I don't know? You keep on scrolling down, then it more yeah, it reveals a bit at a time. Okay, let's see what's next. Yeah, if you need to delete the core, okay, let's say if you want to delete the core, so this is the command. Okay, sometimes we index wrongly, we add some documents, and then we want to redo everything. You can delete the core and recreate one. So this is how you just change the command to delete. Yeah, so you will delete the core. Okay. So the first result page will look like this, the very raw one. Yeah, so still no UI. Yeah, no UI. Yeah. So the one that we have seen, just a specific row, all results. You can use any browser to actually display that, but it's a very raw results. Okay. The next step, next part, what I will show you is one sample UI, so that you have a feel of if there's a sample UI, how does it look like? Okay. But I think before that, we go for a short break first. After we come back, I will show you the UI, and I will show you one more thing, which is how to index a CSV file. Two things. Okay. Yeah. So we take a break, 15 minutes break. So we take a 15 minutes break till, okay, what time? Come back at 3:50. Is it okay? We come back at 3:50. Right. All right. Okay. So take a short break, and then we continue at 3:50. Okay. Yeah. Okay. Welcome back. So let's continue a little bit more on the same data set, but we are going to try out one setting that has a UI, user interface. Okay, and also that setting also allow search without specifying a specific field name. Okay, so let's try it first, and then I will explain more about that particular schema that has been used. Okay, so this setting is it has a configuration folder, okay, that already define the schema. Okay, one thing, and also it has a UI folder. Okay, just now the one that we tested is the core that using the default. Okay, the default setting. Okay, so this one, it has a UI and a specific schema. Okay, so let's take a look at how to do this. Okay. Okay, again, let's go back to the prompt here. Okay, you go back to the prompt. What you need to do now is to create another core, but give it a different name. Okay, so you can type cd dot dot to go up one level, cd dot dot to go up another level. Okay. Then we are going to go to the bin folder again. Okay. So in this bin folder, we will create another core. Okay, so the core name is tag product 2. Okay, tag product 2. But this time we want to specify we want to use a configuration file. Okay, so that configuration file is actually in a folder that comes with the installation. Okay, so you can specify the specific configuration file. That is this folder lah. Sample products config. This file is actually located in. Okay, let me see. Is where this server is in one of the locations. There's a config folder. Okay, config set. Yeah. So in the server Solar config set, this one comes with the installation. If you don't specify any configuration folder, then it will use the default one. But if there is a configuration folder, maybe from other projects that you can use, so you can actually specify. So it will use this configuration set. Okay. So inside this configuration set, it has a UI and it has some a pre-configured schema. Okay. So this is the folder that we are going to use. So when you create the core, we have to specifically say that we are going to use the setting from this. Okay, so you enter. So after you enter, you will see that there's a new core created. Okay, new core created. Okay, so the new core name is tech product 2 underscore C15. Okay, so next one, you are going to add. Okay, add the examples, add the docs. Yeah. So let's add the documents to this new core. Okay, add documents to this new core. Okay, just to make sure the core is there, you can refresh and you can look up your tech product too. Okay, yeah, so you can look up. This is the new one. Okay. It has no document inside. Okay, so you can actually add the documents. Okay. So you can use the same command. So we are going to go back to the example /example. So from bin folder again, you need to go back to the cd example docs folder and run the index, perform the indexing again. Means okay, you're going to run java -jar -ec. Okay, this time remember to specify the second core. Okay, number 2. This is number 2. Okay. Okay, then you're posting to post a jar and all XML again. So the core has been created using the schema from this folder. Okay. Basically, the schema is trained based on the is rated based on the tech product schema. Okay. So now we are going to add the documents. So this is the document. This is the posting part. Okay. So it will add the same series of files. Okay, but I've got a error. You shouldn't get this. I've got one error because I got one additional XML file inside. Okay, this because the fields in this tweets.xml is different from the one defined by the schema. Okay, so it cannot be added. Okay. So if you use predefined schema, there's a pro lah, because if there's some files that doesn't conform to the schema, it cannot be added, just like this one. Okay, so it's it will shows an error lah. It's not going to add. Okay, so the rest will be added. Okay, so once you added, you can go back. Okay, you can yeah, you can try to query using the single word. Okay, just without specifying the field. Okay, so you can try to query using a keyword. So if you refresh, I get 32 because just now that 2 tweets they were not indexed. So now I get the same number as yours. So let's try Maxter. Okay, Maxter and search. Okay, so it will actually match. Okay, the previous, if you choose tag product core, right? If you switch to tag product core, it cannot match without specifying a fields. Okay, so for this schema, it is able to search. It allows us to search across all the fields. Okay, because there's a few lines in the schema that says that, okay, it's over here. There are lines in the schema that says that when we perform indexing, when the document is added to the index, it will actually copy one. It will copy from the, for example, a category field to a destination text field. So this destination text field is the one that is allow us to search across all the fields. Okay, so this is these few lines are. So yeah, for this few a few fields here. So if you search something from the manufacturing, we don't have to specify the fields. Okay, you can search across the this using this text field. Okay, so this is the that part that is happening here. Okay, so I think if you search maybe iPod. So if you search iPod, you can get 3 results. Okay, you get 3 results. So you can also try with other query format. You can try phrasal query, and there are other parts of the forms, for example, like FL. FL, it means that if you add this FL parameter, it allows you to instruct like the system, like I only want this particular fields to return. Because if you, as a search result, if you return so many fields, it's very messy. Not all the fields probably is like is suitable to be displayed as a search result. Okay, some fields may be used for other kind of filtering or matching or metadata, internal metadata. So you can use FL to control what kind of fields that you want to return. Okay, so you can use FL over here. Yeah. So you can specify a specific fields to return. Okay. So for certain field type, we can also apply range query, like from like for example, price. You can apply like specify like from 10 to 100 or 1000 and above. Okay, so it will match lah. So that is not for text. That one is have to be for like numbers, price, and so forth. So this is the query with field list. You can try this. Just play around with the form, arrange. Okay, and then okay, rank retrieval. Okay, we want to take a look at rank retrieval because just now we talked about that the result is actually rank. Okay, the result is rank. So let's try to enter this. Okay, iPod, and this few fields to return. Okay, we know there's a name. Okay, name of the product, features of the product, but score, actually score is the score that for used for the ranking. By default, the score is not displayed, okay, as the part of the search result. So if you want it to display, you have to specifically specify that. Okay, so you try to enter this, and then you will see, yeah, this results. Okay, try this. Okay, so I'm going to look for iPod, and I want to see these 3 fields. Okay, execute. Okay, so you can see there's a score. Yeah, so the score, the search result will be ranked by score. Okay, so this is result number 1, number 2, number 3. Okay, so in the result page, the results can actually be ranked based on this score. So how do we get the score? Yeah, but we don't know exactly the formula that has been used, but it's based on a few factors lah. Okay, based on a few factors. Can you guess the factors? Yeah. How to what is the scores based on? What factors is you have been used to to come up with this score? You can see, okay, our keyword is iPod. The query is iPod. So there are some, okay, basically there are two fields only written over here. The keyword matching, okay, the keyword that matches. You got one keyword here, one keyword here, and another keyword over here. Okay, so yeah, location of the words. Here, I think there's no weighting on the name and features yet. Yeah, but it could be weighted of a certain fields. Yeah, frequency of the words. Yes, also depends on. For example, like this result number 1, it has 1, 2, 3 times, and result number 2 has 1 time. Result number 3 has 1 time. Okay, but if you see result number 2 and number 3 both occur 1 time. This one 1 time, this one 1 time. Okay, the score of this one is much lower. The last one is much lower. So there's another factor. There should be, yeah, at least one more factor that affect the yeah, other than frequency. Yeah. So if you look at the length, the percentage of the words over total words, right, Fahmi? Yeah. So you can see like the result number 3, actually the whole paragraph, the whole document is much bigger. Yeah. So if you compare like iPod only occur 1 time in a big document, the score will be actually normalized lah. Yeah, normalized against the length of the document. Okay, so this, I think I got this one there's a slide about the few factors. So in the scoring model, the few factors are used like TF, the IDF as well. That's why just now there's a lucid index picture, there's one DF, document frequency information captured. So they use inverse document frequency coordination. The more query term found in a document is higher score. Then field normalizations, the more words in a field, okay, the lower its score. Okay, so these are some of the factors used. Okay, lastly, for this part, take a look at the UI. So just now when we use that configuration file, there's one subfolder named velocity. Okay, so velocity is one of the implementations of the search UI. It allows you to actually it's a response writer. Okay, you can read a bit more at I think there's a velocity link. Yeah, here. Yeah, you use this. Okay, let's see how it works. So it looks like this. So you can, it's one way to implement the front end, but there are of course many different ways. Not only this is one of it. You can have other front end to display the search result, fetch and display the search result. Okay. So the middle part here is your local host Solar. This is your core name. Okay, this is your core name. Okay, core name and browse. So this is core number 2. Okay, remember, don't number 1 we don't have the UI. The number 2, this is core number 2. So if you look at this, is okay. The front end is very simple, but the capability is actually similar to the one like the keyword search, just like your admin, but there are some configuration being done to display the results. Okay, if I type iPod again, okay, and submit, so it will the front end has been configured to, okay, the first thing, of course, it fetch the query and it matches. So the query that fetch should be similar like this, okay, this query, but then it will have additional criteria, okay, because you see that the display is like, okay, it actually shows ID, it returns ID, it returns this first line. Okay, this could be the name. Okay, this is the name. Then it has price, features, and in stock is false. Okay, there's no stock for this product. So this is like a search result. And also there's another thing like over here. If you search iPod, the search results. Okay, so search result display these few fields. Before that, when we look at iPod, right, there are other fields like category, manufacturer, content type, and others. Some could be, this one could have a missing of information. Okay, so if there's fields like category, especially, so we can also actually create a UI. This is just another UI for a field. So based on this search result, these 3 results, and according to the category field, there are these keywords that appear in these results. Okay, so if electronics actually 3 times, because these 3 are actually electronics. So from these search results, if you want to further like dive down, if you want to look at which one is actually has to do with music, so you can click music. Okay, so music is actually the Apple iPod only. Okay, so this is another way of using the search results. Yeah, not only display, but it can be used as used for filtering. Okay, so normally like query the category lah, suitable to be used for filtering. Okay, and there's also price range and query phrases. Query phrases actually it suggests more query for you based on some of the clues from the search results. Okay, so if you tick GB, yeah, then you have this. So this is one example front end that we can actually build for when you're using Solar system. Okay, so by the way, this platform is actually open source. So anyone, like you see what, we actually download it and we can start building something on top of it. Yeah, so it's free. Yeah. So if you are familiar with some front end coding, then it can, I think, can have we can actually develop a very nice or a very simple search solutions. Okay, this is the end for the first part. Okay. So I will just show you one more part, the CSV. Okay, but up to now, can you let me know if you can get this core, the second core, and the a simple search interface? Are you able to display this? Okay, we got one. Yeah, at least one. Yeah. Okay, Hanim as well. But frankly, if for velocity response writer, the coding part is quite complicated. There are others easiest way easier way to do the front end UI. But it depends on the programmer's familiarity lah. Yeah. Okay. So this is the first. Okay, I'm going to go to the second. Okay, so just now we talked about CSV as well. Yeah, I think CSV is one of the file type that is more common. How to index CSV file? Okay, so let's move to the CSV. Okay, the slides are actually quite a lot. This one you can actually explore. It's step by step. Okay, this one is the something about document only. Okay, yeah, CSV. Okay, I'm going to go to the CSV. Yeah, how to index CSV file. Okay. I have shared two CSV in the e-learning site. Okay, so you got the CSV file is actually customer complaint. Okay, so there are 200 customer complaint. First 100 in the first file, second 100 in the second file. So we got a total of 200. Okay, customer complaint. So you can just download and place the file in the same folder. Just place in the example docs folder. Okay, so just place in the example docs folder. And okay, we are going to create a new core for complaint. Okay, then after that, we will index the CSV file. Okay. So let's create the core. Okay, we need to go to bin first. Bin. Okay. Just a moment to mute. Okay. So let's go to the bin folder and create another core. Okay. So we name the core complaint. Name the core complaint. For this core, we don't use any configuration. There's no configuration file. Okay. So we have to use the default one. Okay. Yeah. So we just use the default setting. So we call it. So this core is complaint. After that, next step, we will index because the core is empty and we don't have any schema. Okay, there's no schema in the. It's empty. We are going to index for the first time to get the schema. Okay, we are going to index to get the schema. Okay. Oh, okay. By the way, how does this data look like? Data. Go to examples. Okay, so you place your files over here. Okay, CC is a customer complaint, 100. So this is the customer complaint information about a certain product. Okay, you got product, bank account, mortgage. What is the issue? What is the? I think some got sub issue, and which company and so forth. Okay, and the sub products. Let me minimize this. So let's add this file. Okay, so Java document type. So for CSV file, we need to specify the document and then dash jar. This is your core name. Core name and then post calling back the same tool. Okay, the file only one. So we do one first, 100. Okay, this is the file name. C underscore 100 underscore ID. So the check back your command. Document type is CSV dash jar dash DC. Core name, your tool, and the file. Okay, let's enter. I do it at the wrong place. Okay. So, okay, let me go to, yeah, the file is at the example docs, right? Okay, let's go there. We are here. Okay. If you want to access the previous command, you can use the up arrow. So, okay, one file index. So I only have one file index. Okay. So you should, okay, next slide. So we check the total document. Okay, check the total document. Let's go back there. Here. Refresh. Look for the core. So this is our core. We got 100 complaints inside. Okay, we got 100 complaints inside. Okay, you can go to query. Go to query. And let's display everything. Star, star, execute. Yeah. So this is the CSV file. Okay. These are the contents from the CSV file. So now, because we are using the default schema, if we want to search a product, we have to say that I'm going to look for this inverted index list product. I'm going to look for loan. Okay, I'm going to look for loan and execute. Okay, there are 7 product about loan, 7 complaint on the product loan. Okay, so we have to specify the field over here. Okay. So I will show you how to search across, how to modify the schema over here. Okay. But just a quick check. Are you able to index the CSV file? Are you able to index the CSV file and get this? Before we proceed. So the CSV file is, yeah, you just use similarly, you just create the core and just the command different only. We have to go back to example docs and type this command. Okay, but make sure you copy and paste the CSV file inside the folder. The CSV file has to be in your example docs folder, these two. Okay, 1, 2. Yep. Okay, you got error. All right. Okay, go back to command. Wait. Let me see what's the error name. Have you created the core? Okay, go back to my wait, where's my, okay, it's here. I'll take a look at your, shouldn't, fatal error. Do I have a fatal error? No. Okay. Wait, the Java document type, XOCSV. Java. Oh, I know the capital C. Mona, your, I think should be the C, the capital D followed by a small c. Your command. Okay. Okay, Mastura, so this is the, yeah, this is the one. Okay, so once you got it indexed, you should be able to search. But then this, you still have to, because the content, right? All the contents here is actually indexed against the specific fields. So you still have to type the fields because we don't have any config file for this one. What you can do is, there's a slide about it. Not this one. Yeah, create the catch-all copy field. Okay, create the catch-all copy field. We are going to copy the, because now we already got the schema. This one, first round we don't have. Now we already got the schema. So now we want, I'm going to say that those fields, okay, I want to make it easy. All the fields I'm going to copy to text. Okay, yeah. So what I can do is, I'm going to go to the schema tab. Schema tab and add this command. I said source everything. Okay, so I'm going to modify the schema. Star means everything. Destination is underscore text underscore, then add copy field. Okay, add copy field. Okay, where's the tab? Okay, tab is here. So we already got the schema. I'm going to go to schema tab. Okay, and I click here, add copy field. So I will say star. All of the field in my current complaint schema, I'm going to add one copy to the destination. Call this text destination underscore text underscore. Okay, so I'm going to add it. Okay. Okay, so once I add this, it already is updating. The schema already updated. Okay, so the schema will be like the just now one. Every time I index a document, it will copy to the text field as well. Okay, but then the tricky part is this: the document that we have already add, is already fixed. Okay, they already being indexed to product field only. The embedded index already created. So what we need to do now is we need to remove the 100 documents and add back. Okay. So how to remove? So just now we talked about the remove. Go to document, then go to XML. Okay, where is the command? Okay, 70. Okay, 70. This one. Okay, I'm going to delete. Okay, you copy this. I'm going to delete everything. Okay, so now we learn how to delete. Okay, delete everything. Can we get back here? Remember to set to XML because this is an XML command. Okay, so I'm going to delete everything. Okay, and I'm going to submit here. Yeah, so success. You can see here the status success. If I go to let's say overview, number of documents already 0. Okay, no more documents. It's already 0. Yeah, nothing here already. Then how to add back? Okay, so add, go to command prompt and add again lah. So you go to example docs, because now the schema already been updated. We already add the instructions say that whatever you index to that, let's say product fields later, it will copy to the text field. Okay, so I'm going to, you press up button. Okay, so you can, yeah, run again. So this is the first file. Okay, if you want to add the second file, just change the file name. Where's my file name? 101 underscore 200. So it's 101 underscore 200. Okay, double check. Underscore ID. Okay, this is my next 100 lah, the second 100, different one. Okay, different complaints. Okay, so if I add two CSV, I am supposed to get 200 lah. Okay, I'm supposed to get 200. Okay, let's go back here. Overview. Okay, maybe refresh. Yeah, you can see here I got 200 documents. Okay, from my CSV file. Okay, let's query. Okay, I'm going to query everything. Okay, yeah, query everything. You found 200 now. Okay, let me try to look up loan again. Okay, just now I typed loan. Yeah, let's try loan again without any field. Okay, yeah. So let's execute. So 87. I think the second file has more loan keyword. Yeah. Oh yeah, because it's now it's not only searching product, it's searching across others also. Yeah, there are other parts as well. Okay, you got more. So this is the yeah, small modifications. That means you can actually update your schema. Okay, you can actually update your schema. Yeah, you can open up and have to do it carefully lah, but you can update. You can update your schema. And then you can to suit your data lah. Yeah, basically when you update, you need to, because we need to fit in the maybe new data requirement. Okay, so this is the about the complaint. Yeah. So is it how many times did you upload one set or two set? Oh, you need to upload two set. No. Okay, wait. Because the first one you also need to redo because we have deleted already. So there are actually two separate CSV files, two different file name. The first file name is, okay, where is the first file? The first file name is this one. Okay, cc underscore that 100 only. The second file is this one I repeat, sorry. So the second is this one. Yeah, this is the second 100. This is the first one. So actually two files, one file 100. Okay, yeah, so you got 200. There's one part about the, okay, I want to see which part has more text. Okay, you see this one? I'm going to copy this issue. Okay, this is one of the content under issue. Okay, I'm going to copy this. Just copy and show you. Analysis. Okay. In the analysis tab, there's two parts. One is this one, index. Another one is query. This is for analysis only. It actually shows you like if your field contents or value is like this. Okay, this is what we index, what we send in, right? Your field value. How does it look like when it go through the text processing steps? Okay, you can select one option. Let me see, text. Okay, EN, show you text EN pipeline. And I uncheck this, robust. Yeah. So it actually, you see when I run, okay, actually that didn't click also. It show you the steps. If you have a word, if you have the contents, okay, just now this content is in the query, right? This query, issue, one of the issue content. So the content from the CSV come in under the field issue. It will go through this text analysis pipeline and one step after another. So this one come in, it goes through this one, tokenizer. You see this one? Standard tokenizer. This one's my on. Yeah, it goes through the standard tokenizer. The next one is stock filter. So it's going to remove the stock words. Lowercase filter. So you see this one, change to lowercase. So this one is actually happening at the back end. But over here, it allows you to do some analysis based on certain field types. Different field type have different properties that can be configured in the schema. Okay, if you open your schema, you will see under text EN field type. If you index, if the field, okay, if because there can be many fields. Let's say if a product field has the field type text EN, it will go through this pipeline during processing. Okay. So let's say this, after that lowercase, then English possessive handling. This one, no, it didn't detect this one because it's not a possessive. Okay. Set keyword marker filter. This one I'm not so sure what happened, but I think the last one is Porter stammer. Yeah, Porter. Remember stemming? Yeah, we talked about stemming last week. So I somehow mentioned that, okay, I'm going to show you how stemming is done in a real retrieval platform. Okay, so basically this is where it takes place. So the stammer is being used, Porter stammer, in one of the indexing steps. So it comes, this is original content come in step by step. In the end, you get this token. Okay, you get this token. Yeah, so this will be your index. It will be passed to generate to produce the inverted index. Okay. Let's see the query. What if you have a query? Query on the left, right side. Okay, so this say that continue attempts collect that not own. Okay, so if I want to query about some maybe owner that has a, I don't know, app, I just simply make up. Okay, so you analyze, but owner, okay, it doesn't tokenize. I just want to, yeah, I think this stemming probably is a different. I want to see whether the, okay, whether it can match or not. Yeah. So if you have such a query, right, on the right side, attempted and depths, or maybe okay, what about depths? Yeah, something like this. Yeah. So if you have the, at the first place, you don't have the exact match keyword. One is attempted, but your contents attempts. So you have depths and depth, and probably some other variants. So with this step, actually, you are able to, still able to match. So your query come in the end, you get these two match words. Yeah, so this is how the the query part is done also. When the query comes in, it's also going to go through the similar step. Okay, just that it has a additional one. This one is interesting because it's called a synonym graph filter. This graph filter, there's a text file called synonym.txt in that folder. You just need to add the synonym list. If you add the synonym list, like let's say debt, DEBT, you add debt and then you add hutang in Malay, it's going to expand when you key in debts, right? It's going to expand to another word. That means it's going to add debts and then plus hutang also. Yeah, and with the additional words, then it increases the chance to get the match output. Yeah, so this is the part where you can add the synonyms in one of the synonyms text called the synonym.txt. So the rest are I think more or less the same. Yeah, more or less the same. Just that this is the additional one. So this is what happened behind the scene. Yeah. So all this can be configured. Like if you want to have 1, 2, 3, 4, 5, 6, 7 steps, can be configured in the schema file. Yeah. So I'm going to open for questions. Yeah, if you have any, maybe any quick questions, you can ask me. Otherwise, you can also check out like the rest of the slides. It's quite actually the slides follow the step by step. If you want to try out like maybe streets analysis, it's basically the same as what I shown just now. Yeah, this is text analysis. Yeah, so you can check out. So this is a bit more information about the class used in the pre-processing processing steps. Yeah, stop list can also customize. So I will stop here because yeah, there are actually too many slides still. But what you can do is you can just try one by one. But if you still have any question, if you are interested to continue and if you have any question, just send me an email, okay, at my email address. Yeah. Or if you are interested to use this method for your company stuff, and then yeah, you can just drop me a message. So I'm going to skip to the maybe the end. Okay. Maybe the end here. Yeah, I think I just want to emphasize on this point. When you use Solar, right? I think the strength here is you can actually combine the two different types of data, the structured and the unstructured one. Yeah, and it can, despite it's although it's for text search, but it still has the capability of handling the unstructured data. Yeah, so you can actually combine both in one same documents and do the solve the problem at the same time. Yeah, so I think this is the one that I want to emphasize on. Okay, so that's all. So Ed, do you have any questions before you move on to the assessment? So let me just go here. So if you're okay, I remember you still have one consultation project, right? You need to do. If you're interested to work on tax related data, Okay, text-related data, I think the requirement, you will need to have some machine learning elements. So if you want to work on text-related, then I think minimally you need to at least build a classifications model, or yeah. So not only data explorations, you need to try to build one classifier. Okay, so that's a bit of a reminder lah, okay, for those who might want to go for textual data. Okay, so that's one thing lah. Yeah. So if no questions, you can actually try to attempt your post-assessment. Okay, you can attempt your post-assessment quiz. Okay, yeah.
Solar and yesterday the R Studio is almost the same, just different view like that lah.
Actually, it's different. Because our studio is a programming language, right? So, but it has a lot of packages. So, just like Python lah, R Python. So the R and R Studio is you can see it as a programming type of programming language, which is one of the popular one other than Python that you can use to solve some data science problems. Yeah. So when you
So this
use
Solar also can do the classification like the R Studio?
mm,
Okay, not.
no, Solar is more on is a platform, and you can relate Solar is to something like a database systems. Yeah, it's a platform that actually has the capability for you to index the file quickly and to search. You can store the file also. It can act as a file storage. So you can store the information. You can retrieve back the information. Yeah.
Oh, okay. Understand.
It's more like it's more like a
Storage.
platform. Yeah. Storage, retrieval,
Mm.
yeah,
Okay, thank
ranking.
you.
I think if you want to build a classifier on top of Solar, you can. We have to. I think we have to. Let me see. We have to. We have to. We have to get the. We still have to get the contents and then perform the classifications separately lah. Yeah. Yeah, I think we have to involve another external module. Yeah. Maybe integrate with Python or something like that, or R. Yeah.
Okay, thank you, Doctor.
But mostly people use it like for ranking, filtering, just like what the search engine does lah. Yeah. Okay, so can someone try out the post assessment? Yeah, you can let me know whether you can access or not. Okay, let me stop the record.